Hi everybody, welcome to SMR Telugu Education. Next topic is arrays. Arrays. In arrays concept, we have to discuss an operator is called array index operator. Array index operator or array subscript operator. So what is an array? Array is a homogeneous elements, similar type of elements. We want to calculate the sum of 100 elements. We have to declare 100 variables, int a, int b, int c, and so on, 100 variables. It is very difficult to declare a variables. So simply have to define by using arrays is homogeneous elements, same type of elements. This is called derived data type. Derived data type. Array is a derived data type. So how to declare an array? Here you have to mention the type, which type of elements, name of the array, and you have to mention the size, and then semicolon. This is any type of data type. This is variable name, any name. This is size. So data type, variable name, you have to give any name, should be constant. Size should be constant value. Integer constant. Okay. Here we are declaring int array name is arr, and then you have to mention the size. Here I am declaring 10. So for this, the memory is allocated for 10 elements. So I am declaring int arr of 10. So this is the variable name is arr. If you want, you can give any name. This is integer type of how many elements? 10 elements. The continuous memory is allocated for 10 elements. 10 elements. So this is the first, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here the name of the array is arr. So please remember, in arrays the index is always starts from 0. This one is index starts from 0. The name of the array is arr. Here the name of the variable is arr. arr. So every variable has some address. Similarly, array has a addresses. First address is, if you want, you can take any address. I want to take base address is 500. 500. Next address is integer size is 2 bytes. Next address is 502. Next address is 504, 506, 508, 510, 512, 514, 516, 518. The continuous memory is allocated. Here the initial values is garbage value. Any value, some garbage value. So garbage value. So every element has some name. First element name is error of 0, error of 0, so error of 0, error of 1, error of 2, error of 3, error of 4, error of 5, error of 6, error of 7, error of 8, error of 9. So this one is elements. Error of 0 means it gives garbage value. Error of 1 is which type of, this is integer type of element, this is integer type of element. These are the integer pointers. Okay, so first address is 500. It is address of error of 0. Next one is address of error of 1, address of error of 2. Next element is address of error of 3. Next address is address of error of 4. Next address of error of 5, address of error of 6, address of error of 7, address of error of 8, then address of error of 9. So please remember, in arrays, array name and base address both are pointing to the same location. That is the first element of an array. So in array, every array is a pointer constant. So this is a one pointer constant. Array name always gives base address of an array. This base address, this is the array. This array base address is 500. So address of error of 0 and error of both are same. Okay, next, this is the garbage values. If you want to any value in between, it's some integer values, minus 327682, so 32767, any value in between this that is the garbage value. Okay, so please remember, this is the integer constant. The least size of an array is minimum one element. By mistake, if you give 0, then we will get an error. So int error of 0, then we will get an error. So the least size of an array is 1. So int error of, here I am giving int error of some size 10 is equal to, this is initialize an array by using curly braces, open curly brace, close curly brace. I am giving 10, 20, 30, 40 and 50, closed. Here the size of an array is 10. So index starts from 0 to 9, error of 0 to error of 9. So here in this case initial values is garbage values. Here the first element is 10, next element is, here the array is allocated of size 0 to 9, error of 0, error of 1, 0 to 9. Zero to 9. Here the first element is 10, next element is 20, next element is 30, so next element is 40, next element is 50, so remaining elements are 0. So 0, 0, 0, 0, then 0. So please remember, whenever we are initializing an array, the remaining values are zeros. Int size, here I am giving size is equal to 10, int error of, size is an integer type of variable, declaring size, semicolon. Okay, so run this code, we will get an error. So we will get an error. So please remember, here the array is integer constant, integer constants, variables are not allowed. By mistake if you give a variable, you will get an error. Int error of some size 3, array size is 3. Here I am initializing 10, 20, 30, 40, 50. So run this code, we will get an error. Here we are giving array size is 3, but here we are initializing too many initializations, 40, 50 are not allowed. We will run this code, we will get an error. Next, int error of some 10.5. So run this code, we will get an error. Here the size is integer constant, here we are giving double value, that's why we will get an error. Next, int error of array size 2 is equal to, here I am giving 10 and 20. So this is valid. Our array size is 2, first element is error of 0, error of 0, next element is error of 1. Just taking some addresses 500 and then 600. Sorry, integer size is 2 bytes, next value is 502. Here the first value is 10, next value is 20. Next we have to print these two values. Printf %d error of 0, it will give 10. Printf %d error of 1, it gives 20. Here I am giving error of 2 is equal to 30, error of 3 is equal to 40. Here I am printf percentage d, percentage d, percentage d, percentage d, comma error of 0, comma error of 1, comma error of 2, comma error of 3. So run this code, we will get 10, 20, 30, 40 is the output. Here we are giving array size is 2, but we are initializing 4 elements. There is no boundary checking for an array in C language. Note. So there is no boundary checking for an array in C language. This is valid. We have to run this code. Here I am taking file name is array.c. So void main. Here I am declaring array size is int arr of 10. This is continuous memory is allocated for 10 elements. Here I want to debug this code. Watches, remove all watches. So watches, add. Here I am adding array name. What is the name of the array? ARR. So the memory is allocated for 10 continuous elements. Memory is allocated for continuous elements. So F7. So I want to print that values. F7, so small for S. Watch. Undefined symbol ARR. Our execution starts from main method. Void main. Int ARR of 10. So I am printing printf. So memory is allocated for 9 elements. Every element has some address. Here I am giving percentage u, percentage u, percentage u, percentage u for printing addresses. Percentage u, percentage u, percentage u, percentage u, percentage u, comma address is first element is address of error of 0. Next one is address of error of 1. Address of error of 2. Address of error of 3. Address of error of 4. Address of error of 5. Address of error of 6. Address of error of 7. Address of error of 8. Address of error of 9. And I have to print that values. So printf, copy this code, control insert for copy, paste this code, shift insert is the paste. Percentage d, 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 percentage d. Here remove the address operator. First element is error of 0, error of 1, error of 2, error of 3, error of 4, error of 5, error of error of 6, error of 7, error of 8, then error of 9. Okay, so run this code. Execution is always starts from main method. Add watch. Here name of the array is error. So watches, add watch. I am adding array name error F7. Here execution is not start, that's why undefined symbol error. Whenever the control goes to the main function, memory is allocated for 10 elements. So first element error of 0, error of 1, error of 2, error of 3, 4, 5, 6, 7, 8, 9. 0 to 9. Initial values is garbage value. This is the first address. Address of error of 0, address of error of 1, error of 2, 3, and these are the addresses. So F7, Alt F5. So first address is 65,506. Second address is 508, 510, 512, 514, 516. That continuous memory is allocated. So instead of here, I am writing /n /n. These are the values. So these are the addresses. So F2, F7 is Windows watch, undefined symbol, memory is allocated for 10 elements. Alt F5. So these are the addresses, these are the values. So better to write CLR SCR to clear the screen. CLR SCR, clear the screen. So these are the addresses, these are the values. Alt F9 is Control F9. So Alt F5. These are the addresses, these are the garbage values. So please remember, here the array size is integer constant. By mistake, if you give, here I am giving array size is 0, then we will get an error. Comment this code. Alt F9, one error. So array must have at least one element. The least size of an array is one element. Here I am giving array size is 10. Here I am initializing 10, 20, 30, 40, 50. Then remaining elements are zeros, not a garbage values. So run this code, Alt F5, debug this code, F7, Windows, watch, array sizes, initial garbage values. Whenever this statement is executed, first element is 10, 20, 30, 40, 50. Remaining all are 0, 0, 0, 0. So 10, 20, 30, 40, 50. Remaining elements are 0, 0, 0. These are the addresses, these are the values. Alt F5. Okay. So I want to clear this screen every time. CLR SCR. Next. Here I am giving array size is 2, but here I am initializing too many values, 40, 50. Then we will get an error. Alt F9. Here the array size is 1, 2, not 12. Alt F9, one error. Enter. Too many initializers. Here array size is 2, then you have to initialize only 2 values. But if you want, we can initialize the, assign the values. Error of 3 is equal to 30, error of 2 is equal to 30, error of 3 is equal to 40, and so on. But now values, this code is running, control F9, alt F5, 10, 20, 30, 40, remaining are 0, 0, 0. Okay, this is the array, how to initialize. Next, one more thing, here the size, this should be integer constant. By mistake, so comment this code. By mistake here I am giving 20.5, some double value I am giving. Run this code, will get an error. Constant expression required. Okay. So every name, every array has some type. Which type? Same type of values. If you want, you can assign some integers, some constants are not allowed in arrays. Okay. So this is just a declaration. How to declare an array? How to? Every array has some addresses and some values. Array index is starts from 0 to, if size is n, last element is n minus 1. Okay. So thank you for watching. So what is the output of a given program? So what is the output of void main int error of some size 10, elements are 8, 18, 28, 38 and then 48. Int asterisk ptr. So ptr is equal to address of error of 0 plus plus ptr plus plus ptr plus plus asterisk ptr, then printf percentage d comma asterisk ptr. So what is the output of this program? Okay, so our execution is always starts from main method. Here the array size is 5, array name is arr. The memory is allocated for 5 elements. So 5 elements. First element is arr of 0, arr of 1, arr of 2, arr of 3 and arr of 4. Error of 1, error of 2, error of 3, error of 4. Here in some addresses, here I am taking the initial address is 500, next address is 502, next address is 504, 504. Next address is 506, next address is 508. Continuous memory is allocated. Here the name of the array is arr. So name of the array is arr. Array name always gives pointing to first address. So these are the initial values 5, 8. First value is 8, next value is 18, next value is 28, next value is 38, next value is 48. Next, int asterisk ptr. Here memory is allocated for ptr. Ptr is a pointer variable. So memory is allocated for so variable name is ptr, some address I will take 600. So initial value is garbage value. Okay, next this statement is executed. Ptr is equal to address of error of 0. Error of 0 is 8. Address of error of 0 is 500. So this value is this garbage value is replaced with address of error of 0, that is 500. So this value is 500. Next, our ptr is pointing to this address. Okay, so next plus plus ptr, whenever you are incrementing the ptr, it is pointing to next location. This is first variable, first location is 500, next location is 502. Whenever we are incrementing the pointer, it is pointing to the next address. So plus plus ptr means this one is replaced with 502. Now the ptr is pointing to this address. Next, this statement is executed, plus plus ptr, that means ptr is pointing to next location. This is next location is 504. This memory is, this value is replaced with 504. Now the pointer is pointing to this location. Next, this statement is executed, plus plus asterisk ptr. First asterisk ptr is executed, asterisk ptr. So what is ptr? Ptr is 504. Asterisk ptr means 504 address variable, that is ARR of 2. So here ARR of 2 plus plus, that means ARR of 2 plus plus means this value is incremented by 1. So this value is 29. Next, this statement is executed, printf percentage is d asterisk ptr. What is ptr? 504. What is asterisk ptr? Asterisk ptr means ptr is 504. Asterisk ptr means 504 address variable, that is ARR of 2. Indirectly ARR of 2 value is 29. So 29 is printed output. Okay. So we want to execute this code. So file name is array1.c f5 void main. Here I am declaring array of size 5. So assign the values 8, 18, 28, 38, 48. So int asterisk ptr. So clear the screen, clr scr. ptr is equal to address of ARR of 0. So plus plus ptr means ptr is pointing to next address, plus plus ptr plus plus asterisk ptr, and then printf percentage d comma address of asterisk ptr. So debug this code. Want to add watches of array name is ARR. So F7. So memory is allocated 5 elements. First element is 10, 20, 30, 40, 50. Here ptr. So want to add ptr. So ptr default value is some garbage value. Now the address of ARR of 0 is stored in ptr ffec plus plus ptr. Ptr value changed to next address. This value is changed to ffee. Next plus plus ptr. Next ptr is pointing to this address. This value is changed. Next asterisk ptr. Asterisk ptr means this address variable, that is ARR of 2 is increment by one value. This value is changed to 29. This value is changed to 29. So PTR is this address, asterisk PTR is this address variable, that is ARR of 2, value is 29. So F5, so output is 29. So please remember, the base address of an array and the first element address of ARR of 0 both are same. So instead of I am writing address of ARR of 0, direct I am writing ARR, both are same. So Alt F9, yes, F7. So A PTR, this value is changed to 29 and then 29. Alt F5. Okay, so this is the array with pointers. Thank you for watching. Hi everybody, welcome to SMR Telugu Education. So next topic is, what is the output of a given program? Void main int ARR of size 10. I will take size is 5. Take their elements 10, 14, 24, 34, then 44. So plus ARR plus asterisk ARR plus asterisk ARR printf %d comma asterisk ARR. So what is the output of this program? Okay, so you have to run this code. Here array size is 5, the memory is allocated for 5 elements. So first element, second element, third, fourth and fifth. Here the name of the array is ARR. So first array element is ARR of 0, ARR of 1, next element ARR of 2, next element ARR of 3, next element ARR of 4. So every array has first element is 4, next one 14, 24, 34, then 44. Here the starting address is, I will take 500, next address is 502, next address is 504, next address is 506, next address is 508. Here the name of the array is ARR. So array name always pointing the address of the first element. So next this statement is executed. So we have to run this code. What is ARR? ARR is the address of base array. This array base address is 500. Here ARR is 500. Whenever we are applying plus operator on constants, then we will get an error. We have to run this code. We will get an error. So please remember, array name always gives base address of an array. So array name is a pointer constant. So array name is a pointer constant. So that's why we will have to, that's why here we have to get the error. To execute this code, Alt F new F2. I will take file name is point array3 C, F5, void main. Here we are declaring int array of size is 5, elements are 4, 14, 24, 24, 34, 44. Here plus plus arr plus plus asterisk arr plus plus asterisk arr, then printf percentage d comma asterisk arr. So alt F5, run this code, will get an error. So this is the error. This is the arr is the array name. Array name always gives pointer base address of an array. It is a pointer constant. That way you will get an error. Okay. So here commenting this line, then so I want to comment this line. Comment this line. What is ARR? ARR is 500. So what is asterisk ARR? Asterisk means 500 address variable, that is ARR of 0. ARR of 0 increment by 1. That means this value is replaced with 5. Next, once again asterisk ARR. ARR means 500. Asterisk means error of 0 is increment by 1. That means 5 value is increment by 1. This value is 6. So here asterisk printf percentage d asterisk arr. What is arr? 500. Asterisk arr 500 address variable, that is arr of 0. That value is equal to 6. Here I am writing CLRS here to clear the screen. So alt F5, yes, control F5. So output is alt F5. Output is 6. So how to debug this code? F7. So array name is ARR Windows Watch. So F7, memory is allocated for 5 elements. First element is 4, 14, 24, 34, 44. Asterisk ARR. First element, this value is increment by 1. Whenever complete this execution of this statement, this value is 5. Once again, ARR means first address of, asterisk means this ARR of 0 increment by 1. This value is 6. Once again, ARR is base address of array. Asterisk means this value 6 is printed. Alt F5, 6 is the output. Hi everybody, welcome to SMR Telugu Education. So next one is, what is the output of a given program? So void main int arr of, will take some size a is equal to, array size is 5, first element 9, 19, 29, 39, 49. So int asterisk ptr. So ptr is equal to, just here I am printing printf percentage d space percentage d space percentage d space percentage d comma arr of 2 comma 2 of arr comma asterisk of arr plus 2 comma asterisk of 2 plus arr. So what is the output of this program? Okay. So here arr of 5 is, memory is allocated for 5 elements. So the array size is the memory is allocated for 5 elements. So first element is first, second, third, fourth, fifth. First array name is error of 0. So next one is error of 1. Next one is error of 2. Next one is error of 3. Next one is error of 4. So every array some base address. Here I am taking 500. Next address is 502. Next address 504. Next address 506. Next address 508. If the values is first starting value is 9. Next one is 19, 29, 39, 49. Here the base array name is pointing to first location. Here the name of an array is ARR. So here what is ARR? ARR is equal to array name always gives base address of an array. Here the base address of an array is 500. ARR is 500. So what is asterisk ARR? Asterisk ARR is 500 address variable, that is ARR of 0. ARR of 0, that value is equal to 9. So what is ARR plus 1? So whenever ARR is base address of an array, whenever we adding one value to the address, it is pointing to next address. That means ARR plus 1, the value is equal to the value is equal to 502. So what is asterisk ARR plus 1? So ARR plus 1 is 502. Asterisk means 502 address variable, that is ARR of 1. ARR of 1, this value is equal to 19. Next one is ARR of plus 2, value is equal to next address. ARR plus 2 is equal to 504. Asterisk means asterisk ARR plus 2. 504 address variable, that is ARR of 2. This value is equal to ARR of 2. So ARR of 2 value is equal to 29. So ARR of 2 value is equal to 29. Similarly, this is asterisk ARR of 2. ARR of 2 can be written as asterisk ARR of 2. This asterisk ARR plus 2 is also written in the form of asterisk ARR 2 plus ARR. Both are same. This value is equal to ARR of 2. This value is equal to 29. Similarly, manu ARR of 2 can be written as 2 of ARR. This is also can be written as asterisk 2 plus ARR. So this value is equal to ARR of 2, that value is equal to 29. So you have to run this code. ARR of 2 value is 29. 2 ARR of 2 of ARR value is equal to 29. Asterisk ARR plus 2 value is 29. Asterisk 2 plus ARR value is equal to 29. So now ARR of 4 can be written as asterisk ARR plus 4. So ARR of 4 can be written as asterisk ARR plus 4, or 4 of ARR can be written as asterisk 4 plus ARR of. All are same. You have to run this code. New file F2. So take file name is arr4.c. So void main. So int arr of 5 will take array size equal to 5. Values are 9, 19, 29, 39, 49. Here printf %d space %d space %d space %d comma arr of 2 comma 2 of arr comma asterisk arr plus 2 comma asterisk 2 plus arr. So all are same. Here clear the screen. CLR SCR F2 save. Alt F9 yes. Debug this code. Initial starting value is 9, 19, 29, 39, 49. Error of 2 values 29. Alt F5 29, 29, 29. Hi everybody, welcome to SMR Telugu Education. So next one is, what is the output of a given program? So void main. We are declaring array size is 5. Assign the values are 8, 18, 28, 38, 48. So int asterisk ptr. So ptr is equal to arr plus 1. So ptr plus plus or plus plus ptr, anything plus plus ptr plus plus asterisk ptr next plus plus ptr minus minus asterisk ptr, then printf %d %d comma ptr of -1 comma ptr of 0 comma ptr of 1. So what is the output of a given program? Okay, here the array size is 5. So memory is allocated for 5 elements. So first element, second element, third, and then fourth. The name of the array is arr. The first element is arr of 0, next element arr of 1, next one is arr of 2, arr of 3, arr of 4. With the base addresses, first address is I am taking 500, next address is 502, next address is 504, next address is 506, next address is 508. So first element is 8, next one is 18, next element 28, next element 38, next element is 48. So int asterisk ptr. Ptr is a pointer variable. The memory is allocated for ptr. Variable name is ptr. So I will take some base address 600. Initial value is garbage value. Next, ptr is equal to, this is the base address. Array name always gives base address of an array. So ARR. So ARR value is base address of an array. Base address of an array is 500. Okay, next, ptr is equal to ARR plus 1. ARR plus 1 means it is pointing to next address. Next address is 502. 502 is stored in ptr. So this value is replaced with 502. 502. Now ptr is pointing to this address. Next, plus ptr, that means the ptr is increment by 1. Okay, ptr value is 502, it is increment by 1. That means whenever we have to increment the pointer, it is pointing to next location. Okay, so this is integer pointer. Whenever you are increment the 1, it is increment by next address, that is 504. This can be replaced with 504. Now this one is pointing to this address. Next, so ptr means 504, asterisk ptr means 504 address variable, that is ARR of 2 is increment by 1 plus plus. That means this value is increment by 1. This value is 29. Next, plus ptr. Next, ptr is pointing to next location. Here next address is 506. 506. Now the pointer is pointing to this location. Okay, next one. The statement is executed. What is ptr? Ptr is 506. What is asterisk ptr? 506 address variable, that is ARR of 3 is decrement by 1 minus minus. That means this value is decrement by 1. This value should be replaced with 37. Next, ptr of minus 1, ptr of 0, ptr of 1. So ptr of 1 can be written as ptr of minus 1 can be written as asterisk ptr minus 1. So what is ptr? 506. Minus 1 means it is pointing to previous address. 504. Asterisk means asterisk of 504. Asterisk means 504 address variable, that is ARR of 2. So ARR of 2 value is 29. ARR of 2. This value is equal to 29. Next, ptr of 0. So ptr of 0 can be written as asterisk ptr plus 0. So ptr is 506. Asterisk means 506 address variable, that is ARR of 3. So ARR of 3 value is 39. 7. Next, PTR of 1, that this can be written as asterisk PTR plus 1. So asterisk PTR is 506, asterisk means plus 1 means it is pointing to next address. This value asterisk means 508 address variable, error of 4. Error of 4 value is 48. We have to run this code. The output is 29, 37 and 48. We have to run this code. Void main, save this file f2. So file name is error of 5.c. So void main int error of 5. So values is 8, 18, 28, 38, 48. So int asterisk of PTR. PTR is equal to error plus 1. So plus PTR plus asterisk PTR plus PTR minus asterisk PTR. So printf %d space %d space %d comma PTR minus 1 comma PTR of 0 comma PTR of 1. So F7 array size. Here I am declare debug. I will also adding PTR value. So initial value is garbage value. Next address is error plus 1 means error of 1 address, F7 address. Now PTR is pointing to this value. Next PTR is incremented by 1. It is pointing to 28. This value is changed. Next asterisk PTR means error of 2. This value is incremented by 1. This is 29. This value is 29. Next PTR value is pointing to this address. Address is changed. Next asterisk PTR is error of 3. It is decrement by 1. This is 37. Next PTR. Now PTR is pointing to 37. PTR minus 1 means pointing to previous address. This is 29. PTR of 0 means 37. PTR of 1 means pointing to the next address 48. So alt F5. So output is just to clear the screen. CLR SCR F2 alt F9, yes, control F9, alt F5, 29, 37, 48. Hi everybody, welcome to SMR Telugu Education. So next one is, what is the output of a given program? So in this program, what is the output of a given program? So in this, our execution is always starts from main function, and A, B, C are the single dimensional arrays. Memory is allocated for A, A size is 4 elements. First one, second one, third one. Here the name first element is A of 0, A of 0. Next one is A of 1, A of 2, A of 3. Next, first address is 500. Next address is 502, 504, 506. Next, one more array of size 3 element 4. Array name is B. First element, second element, third element. Here the first array values are, first value is 4, next one is 14, next one is 24, next one is 34. Here the array name is B. So first element is B of 0, B of 0, B of 1, B of 2, B of 3. So here addresses is, first address is 600, next address is 602, 603, 604, 606. Six not 4, 6 not 6. Here the values are, first element is 6, next one is 16, next one is 26, next value is 36. Next array name is C. So C of 0, C of 1, C of 2, C of 3. So C of 0, C of 1, C of 2, C of 3. Here the base address is 700, next address is 702, next address is 704, next address is 706. The elements are, first element is 9, next one is 19, next one is 29, 39. Here the PTR3 is int star PTR, that means array of size 3 elements. PTR is a variable name is PTR. First element is PTR of 0, PTR of 1, PTR of 2. Pointer, array of integer pointer. PTR is a array variable of type integer pointer. So here the variable name is PTR. First element is PTR of 0, next element is PTR of 1, next element is PTR of 2. Here taking base address is 600, next address is 800, next address is 802, next address is 804. So initial values is garbage values. This one is garbage value, then garbage value. Next, int star star PPTR. Here the name of array is PPTR. Name of array is PTR. This array name is A. So array name always gives base address of an array. This array name is This array name is B. This array name is C. So array name always gives base address of an array. This array name is ptr. Ptr also always gives base address of an array. Next, int asterisk pptr. The variable name is pptr, some address 900. So initial value is garbage value. Next, int I. I is a one variable. Memory is allocated for I. The variable name is I. Some address I will take 950. So initial value is garbage value. Next, what is A? A is a base address of an array. Here the base address of array is 500. 500 is stored in ptr of 0. So ptr of 0, this garbage value is replaced with this value is replaced with 500. 500. Now ptr of 0 is pointing to this element. Next, ptr of 1 is equal to b. B value is 600. Base address of array 600 is stored in ptr of 1. Now this pointer is pointing to this address. Next, ptr2 is equal to c. C is gives base address of array which is 700. That 700 is stored in ptr of 2. Now this pointer is pointing to next. Pptr is equal to ptr. So what is ptr? Ptr is base address of this array. Base address of this array is 800. This 800 is stored in pptr. So this value is replaced with 800. Now pptr is pointing to this address. Next, I is equal to 1. This garbage value is replaced with 1. So value of I is 1. So 1 less than or equal to 3. Yes, condition true. This statement is executed. So what is pptr? Pptr value is 800. So what is asterisk pptr? Asterisk pptr is 800 address variable, that is ptr of 0. Ptr of 0 pptr is 800 asterisk pptr is 800 address variable ptr of 0, that is 500, is increment by I, that value is 1. So asterisk pptr is equal to asterisk pptr plus 1, that means this value is increment by 1. This should be replaced with 502. Now this one is pointing to 502. This one is reallocated. Next, asterisk pptr plus is equal to asterisk pptr plus I. So what is pptr? Here the pptr is 800, asterisk pptr is 800 address variable ptr of 0, that value is 502. Asterisk means 502 address variable. 502 address variable is a of 1 is increment by 1, that means ar of 1 is 14 plus 1. Now this value is 15. Next, plus pptr. So pptr value is increment by 1. So this value is equal to 802. Now this one is pointing to 802. So this pointer is deallocated. Next, I value is increment by 1. So I value is 2. So 2 less than or equal to 3. Yes, condition true. Asterisk pptr. Pptr is 802. Asterisk means 802 address variable. This one is increment by I value is 2. Increment by 2. That means this is integer pointer. Plus 1 means pointing to next address 602. Plus 1 means pointing to next address 604. Now this one is pointing to this address. This memory is deallocated. Now, so asterisk pptr, asterisk pptr plus equal to I. So asterisk pptr is 602 address variable, that is ptr of 1. Asterisk means this value is 604. Now this point is pointing to 604. So asterisk pptr means 604 address variable, that is b of 2 is increment by 2. This value is increment by 2, that value is 24. 8. Next, plus plus PPTR. So PPTR value is increment by 1. So this value is increment by 1. That is next to address 604. Now this one is pointing to 604. 804. Now this memory is, this link is deallocated. Now PPTR is 804, asterisk PPTR is 804 address variable, that is PTR of 2 is increment by I value is 3. Here the I value changed to 3. So 3 less than or equal to 3 as condition true, asterisk PPTR is increment by I, that is asterisk PPTR plus 3. So PPTR is 804, asterisk PPTR is PTR 2 increment by 3. That means this value is 706. Now this one is pointing to this value. Asterisk PPTR. PPTR is 804, asterisk PPTR is 706. Asterisk means 706 address variable. C3 is increment by 3. That means this value is increment by 3, that is 42. Next, plus plus PPTR. Next, PPTR is increment by 1. That means this value is 806. Next, I value is 4. 4 less than or equal to 3. Condition false, out of the loop. Next, minus minus PPTR. PPTR is 806. Minus minus means 804. So PPTR value is 804. Now this one is pointing to this address. Next, what is asterisk PPTR? PPTR is 804. Asterisk means PTR of 2. Asterisk means 706 variable C3. C3 is 42. Here the 42 is printed. 42. So next one is I is equal to 0. Once again I value is 0. 0 less than 3. Condition true. Asterisk PTR of 0. PTR of 0 is 502. Asterisk means 502 address variable A1. That value is 15. 15. Next, I value is 1. 1 less than 3. Condition true. PTR of 1. Asterisk PTR of 1. PTR of 1 is 604. Asterisk means 604 address variable, that is B2. B2 value is 42. 28. Next, I value is 2. 2 less than 3. Yes, condition true. Asterisk PTR of 2. PTR of 2 is 706. asterisk means 706 address variable C3. So value is 42. 42 is printed. Next I value is 3. 3 less than 3 condition false, out of the loop. Next for I is equal to 0, I less than 4, I less than 4, 0 less than 4, condition true. A of 0, B of 0, C of 0. A of 0 is 4, A of 0 is 4, B of 0 is 6, C of 0 is 9. So here the output is 4 space 6 space 9. Next I value is 1, 1 less than 4, condition true. A of 1, B of 1, C of 1, 15, 16, 19. Next I value is 2, 2 less than 4, condition true. A of 2, B of 2, C of 2. Next I value is 3, so 3 less than 4, condition true. A of 3, B of 3, C of 3. That value is 42. Next I value is 4, 4 less than 4, condition false, out of the loop. Okay, this is the output. So we have to run this code. So alt F9, yes, control F9, alt F5. So A value is asterisk asterisk PPTR is 42, star asterisk PTR of 0, asterisk PTR of 1, asterisk PTR of 2, 15, 28, 42. A of 0, B of 0, C of 0, 4, 6, 9. B of 1, C of 1, A of 1, B of 1, C of 1. Next values are A of 2, B of 2, C of 2. Next one I will use A of 3, B of 3, C of 3. So F7. So how to debug this code? A, B, C. Next PTR of 3, PPTR. Next here I value, we are adding I. So starting value is A, B, C, memory is allocated, A, B, C, PTR, starting address. A address is stored in PTR of 0, this one is B value, B address is stored in PTR of 1, C address is stored in PTR of. Next PPTR is equal to PTR, this base address is stored in PPTR. I is equal to next I is equal to 0, PPTR plus I. So this value, this address, first this address is changed. PPTR is this one, asterisk PPTR is this address is incremented by 1. This value is changed. E changed to F0. Next asterisk means this address is this one. This value is incremented by 1. That one 14 value should be 15. This value should be 15. Next plus PPTR. This value is incremented by 1. Now this one is I value is 1, 2, 2 less than or equal to 3. Now this address is changed. EA. Now this address is 604, 601, 2, 3. This is the 604 address. Now this one is pointing to this address. Asterisk means B of 2 is incremented by 2. This value is 28. This value changed to 28. Next plus PPTR. Next this value is increment by 1. This one is pointing to this address DC. Next I value is 3. 3 less than or equal to 3 as condition true. Now this address is changed to 706. This value is changed. Now this one is pointing to this address. Asterisk means this address. Asterisk means C of 3 is increment by 3. This value is changed to 42. Now this value is 42 plus PPTR. Now this value is changed. Once again we are decrementing. Once again this is pointing to previous address. Now this address is pointing to this one. Asterisk PTR is this one. Asterisk means this value 42. So this statement prints 42. Alt F5, output is 42. Now so I is equal to 0. PTR of this address is pointing to this one. Asterisk PTR of 0 is 15. Next this address is pointing to this one. Asterisk PTR of 1 is 28. Next this address is pointing to this one. Asterisk PTR of 2 is 42. First one F5, first value is 15. 15 is printed. Next value is Alt F5, 28 is printed. Next F7, Alt F5, 42 is printed. Next this one is A of 0, B of 0, C of 0. A of 0, B of 0, C of 0. 4, 6, 9 is printed. F5, 4, 6, 9. Second time 15, 16, 19. Alt F5. Next one 24, 28, 29. F7, Alt F5. Next one 34, 36, 42. Alt F5. Next F7 out of the body. Hi everybody, welcome to SMR Telugu Education. So next topic is write a program to find sum of sum and average of a given array. Okay. So first you have to declare one array of size. Here I am fixing the size. Array size is 10. You have to declare array size is 10. Year of 0, year of 1, year of 2, year of 3, 4, 5, 6, 7, 8, 9, 10. Okay. Array size is fixed. How to declare? Int error of array size is 10. Next, here the array elements are error of 0, error of 1 up to error of 9. Error of 9. Error of 9. So this is the address. First address is address of error of 0. Next one is address of error of 1, address of error of up to address of error of 9. Okay. First you have to scan the values. Here ask the end user to enter the values. So printf enter 10 array elements. 10 array elements and scan the values. Here I am writing for loop for I is equal to index starts from 0, so I less than 10, I plus plus. So scanf %d comma address of error of I. So whenever this statement is executed first time, this is the address of error of 0. First entered value is 10. This is stored in error of 0. Address of error of 0. It is second time, next address. Third time, next address. Fourth, next value. Fifth. This loop is repeated 10 times. 10 elements are stored in our array. For suppose here we are entering 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So array size 10 means 0 to n minus 1. Okay, now we are the entering the values. Now you have to calculate the sum of first element, AR of 0 plus AR of 1, AR of 2, AR of 3, and so on up to AR of 9. We have to calculate the sum. Initially you have to declare integer sum. Initial value is 0. You have to calculate the sum of each element. Once again you have to write the loop I is equal to 0, I less than 10, I plus plus. So for every time, first time sum is equal to sum plus ARR of I. Whenever this statement is this loop is executed, first time 10 is added to sum, second time 20, next time 30, and so on up to 100. Okay, the sum is calculated. Next you have to print sum. Print sum is equal to percentage d comma sum. Then you have to find out the average. Printf average is equal to, so initially here I am declaring some float value, float average is equal to, initial value is 0.0. Here the average is equal to sum by number of elements 10, and then print the average. Printf average is equal to percentage f comma average. Okay, so to run this code, write this code, alt f new f5 f2 sum dot c. So I am declaring array size is 10. So int error of 10. Next for sum you have to declare sum is equal to 0. For average and declaring float average. For loop purpose I am declaring f I or I. Okay. Next ask the user printf enter array elements. Next scan that values I is equal to 0, I less than 10, I plus plus. So scanf. If you want, you can ask the enter first element, second element, third element message. So printf enter percentage d element comma I. Here the starting value is I value is 0, that's why here I am writing I plus 1. Here enter first element first time, second time enter second element, and the scanf percentage d comma address of ARR of I. Okay, where scan the values. Next you have to calculate the sum. So once again for I is equal to 0, I less than 10, I plus plus. So sum is equal to sum plus ARR of I. After executing this code, sum is present in sum of array elements is percentage d comma sum. Next we have to calculate the average. So average is equal to sum by 10. So here better to convert, or I am taking 10.0. So here I am converting this to float. Here average default value, no need to initialize, default value 0.0. Next printf average of array elements is percentage f comma average. Here just use clear the screen, clr ser f2, save this one. So first you have to debug this code. So delete watch of ptr. Delete. Here you have to add average and sum. Add sum and average. So F7. So initial values is garbage values, sum initial value, garbage value, take sum is equal to 0. Float is also some garbage value 0.0. So enter array elements. Alt F5 it shows enter array elements. F7. So enter first array element and enter the first element 10. Once again F7. This loop is repeated total, so 10 times. Second time enter second element 20. Third time 30. Fourth time 40. Next time 50. F7. Next time 60. Next time 70. Next time 80. Next time 90. F7 100. So this loop is repeated 10 times. Next I value is 10, condition false, out of the loop. Now you have to, this loop is repeated so 10 times. First time sum value is initial 0, 0 plus 10. This sum value is 10. Look at here 10. Second time high value is 1, 1 less than 10, true. Year of 1 20, 10 plus 20 30. Next time 30 plus 30 60, 60 plus 40 100. Next 100 plus 50 150 plus 60 210. Next one plus 70 280. Next plus 80 360 plus 90 450. Next plus 100 550. The sum of array elements is 550. Alt F5. The sum of array elements is 550. Next 550 can be converted into float. Next divided by 10. 55.0. The average of array elements is Alt F5. Average of array elements is 55.6 decimal place. Hi everybody, welcome to SMR Telugu Education. So next topic is write a program to find minimum value and minimum index. Maximum value maximum index of given array. Write a program to find minimum value and minimum index, maximum value and maximum index of a given array. Here we have to take array size is 10. 10 elements. First element, second, third, fourth, fifth, sixth, 7, 8, 9, 10. Here I am taking the base addresses 500, 502, 502, 504, 506, 508, 510, 512, 514, 516, 518. The first element is ARR of, here I am declaring array name is ARR, the base address, take array name as ARR. So first element is ARR of 0, ARR of 1, ARR of 2, ARR of 3, ARR of 4, ARR of 5, ARR of 6, ARR of 7, ARR of 8, ARR of 9. So 7, 8, 9. So initial values are some garbage values. Here I am entering some values. Entering values are 5, 9, some 4, some 10, then 8, take 28, take entering 3, 6, 21, and then 1. So in this program you have to find the, in this array you have to find the minimum value and minimum index. Here the minimum value is 9. In this example the minimum value is 9, the minimum value is 1, minimum index is 9. What is the maximum value? Maximum value is 28 and maximum index is 5. Okay, so how to calculate these values? Here I am taking the first array element, I am taken as minimum value and maximum value, minimum index and maximum index. Here you have to declare variables. So minimum value is equal to ARR of 0 and minimum index is equal to 0. Next, maximum value is equal to ARR of 0. Here I am taking maximum value is 5 and then maximum index is 0. Okay, so first I am taking the first element, ARR of 0 is minimum value, minimum index, maximum value and maximum index. Now I am comparing from these values. We are comparing from ARR of 1 to all these values. So in first iteration, here I am taking first value is ARR of 1, ARR of 1, okay. So now we have to compare the minimum value. Already we are comparing from array of 1 to 9. Here the initial value is, starting value is fixed. Starting value is, here I am taking I value is, starting value is 1. So I less than or equal to, up to last values we are comparing from 1 to 9 and I plus plus. I plus plus. This is the loop. Here what is the value of I? Here the value of I is this is I. So I value is 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, first you have to compare first element ARR of 1 with the minimum value and ARR of 1 with the maximum value. So here I am checking this particular condition is true. That means if you have to check the condition, if we have to compare minimum value and ARR of I value. Here I is starting from 1. We have to compare these two values. Whenever the minimum value is greater than ARR of I. So this condition is true. That means the minimum value is, you have to change the minimum value. Minimum value is ARR of I. And then minimum index is I value. I value. So once again you have to check the condition if maximum value and ARR of I value. Once again you have to check if you have to compare maximum value and ARR of I value. We have to compare these two values. Whenever the maximum value is less than ARR of I, that means ARR of I value is maximum, then you have to assign maximum is equal to ARR of I, and then maximum index is equal to I. So first you have to check this condition with I is equal to 1. Okay, first I is equal to 1, yes, condition I is equal to 1, I less than or equal to 9, yes, condition true. We have to check ARR of I, ARR of 1 with the minimum value. Minimum value is, what is the minimum value? Here the minimum value is minimum value, maximum value, minimum index, maximum index. This is minimum, this is maximum. This is index, minimum index, this is maximum index. Okay, so initial value minimum is equal to error of 0. Error of 0 is 5. So here the minimum value is 5. Maximum minimum index is 0. Then maximum value is error of 0. Maximum value is 5. And then maximum index is 0. Now we are comparing these two values. So a of I is equal to, అక్కడ I value is 1, I less than or equal to 9. Yes, condition true. If minimum value is 5, 5 greater than or equal to, minimum value is 5, 5 greater than or equal to error of I. Error of I is 9. So 5 greater than or equal to 9. Condition false. The statements are not executed. Next, maximum value is 5, 5 less than error of I. Error of I value is 9. Yes, condition true. Then maximum value is, this maximum value is replaced with error of I. Error of I value is 1, error of 1, that value is 9. Here the maximum value is 9. Then maximum index is I. Here maximum index is 0 is replaced with 1. Next, I value is incremented. Here the maximum value is 9 and then maximum index is 1. Next, I value is incremented by 1. I value is 2. Now you have to check error of 2 with error of 2 with the minimum value. Here the minimum value is 5. So 5 greater than error of 5, 4. 5 greater than 4. Yes, condition true. Then the minimum value is error of 5. That means the minimum value is 5 is replaced with 4 and then minimum index is I. The minimum index is I. I value is 2. Next, once again check this condition. Maximum value is 9. 9 less than error of 5. Error of 5 value is 4. 4, 9 less than 4. So condition fail. The statements are not executed. Next, psi value is increment by I value is increment by 3. Once again you have to check 3 value to error of 3. So minimum value is 4. 4 greater than error of 5, 10. So condition fail. These statements are not executed. Next, maximum value is 9. So 9 less than error of 5. Error of 5 value is 10. So 9 less than 10. Yes, condition true. Then maximum value is 9 is replaced with error of I value 10 and the maximum index is replaced with I value is 3. Next, I value is increment by 4. Next, I value is increment by 4. So error of I value is 8. Error of 4 value is 8. So minimum value is 4. So 4 greater than error of I value is 8. 4 greater than 8. Condition false. These statements are not executed. Next, maximum value is 10. 10 less than 8. 10 less than 8. Condition false. So these statements are not executed. Next, I value is increment by 5. Next I value is 5. Now we have to check error of 5 value. So 5 less than 9, yes, condition true. Here the minimum value is 4 greater than error of 5 value is 28. 4 greater than 28, condition false. These statements are not executed. Next, max value is 10. So 10 less than 28, yes, condition true. Then maximum value is replaced with error of 5. Error of 5 value is 28. Next, maximum index is 5. Here maximum index is replaced with 5. Next, I value is incremented by 6. The minimum value is 4. Next, I value is incremented by 6. Now error of I means error of 6. Minimum value is 4. 4 greater than error of 6. 3. 4 greater than 3. Yes, condition true. Then minimum value is, this one is replaced with 3. Next, minimum index is replaced with I value. Index value is 6. Next, maximum value is 28. 28 less than error of 5. Error of 5 value is 3. 28 less than 3. Condition false. These statements are not executed. Next, I value is increment by 7. Next, I value is 7. Now error of 7 value is 6. If the minimum value is 3, so 3 greater than error of 5, 6. 6. 3 greater than 6. Condition fail. These statements are not executed. Next, maximum value is 28. So 28 less than error of 5, 6. This condition is also failed. These statements are not executed. Next, I value is incremented by 1. Next, I value is 8. Next, minimum value is 3. So 3 greater than error of 8, 21. 3 greater than 21. Condition fail. These statements are not executed. Next, maximum value is 28. 28 less than error of 5, 21. 28 less than 21. Condition fail. These statements are not executed. Next, I value is incremented by 1. Next, I value is 9. Next, minimum value is 3. 3 greater than error of I. Error of 1. 3 greater than 1. Yes, condition true. Then minimum value is 1. This value is replaced with 1. Minimum index is 9. Next, maximum value is 28. 28 less than error of 5, 1. Condition fail. These statements are not executed. Next, I value is increment by 10. Next, 10 less than 9. Condition fail, out of the loop. Okay. After execution of this code, the minimum value is present in which variable? The minimum value is the minimum value is 1, which is minimum index is 9, maximum value is 28, maximum index is 5. We have to print these values. Okay, now how to first we know how to convert this code. Okay, now we have to convert this one into our C program. Now how many variables you have to declare in this code? You have to use how many variables? One is integer variable, integer array of size 10, next minimum and minimum index, maximum and maximum index. Okay, next you have to scan the array elements. After scanning you have to enter the same values 5, 9, 4, 8, 10, 8, 28, 3, 6, 21 and 8. Now you have to convert this code. Declare how many variables? Minimum, minimum index, maximum index, I for loop. Okay, now we have to convert this one into our C program. How to convert this one into our C code? So F2 I will take file name is minimum.c. Okay, so void main. Here you have to use how many variables? Int array of size 10. Next we are using int minimum value, minimum, int maximum, int minimum index, int maximum index. Next loop purpose you have to use I. Okay, next I am using CLRS here to clear the screen and ask the end user to scan the array elements. So printf enter 10 array elements. And scanf percentage d comma. Okay, how many elements you have to scan? Array of 0 to array of 9. Next here I am writing loop I is equal to 0, I less than 10, I plus plus 0 to 9. Here I am asking printf /n enter first element, enter percentage d element. Here I am writing I plus 1. I value initial I value 0. That's why I am writing I plus 1 and scanf percentage d comma address of error of I. Okay, after scanning, first you have to assign minimum value is equal to error of 0 and maximum value is equal to error of 0, maximum index is equal to 0, then minimum index is equal to 0. Okay, so instead of writing 4 statements, here simply write minimum is equal to maximum is equal to error of 0, minimum index is equal to maximum index is equal to 0. Here you have to write the logic for you have to compare first element to ninth element. You have to write for I is equal to 1 to I less than 10, I plus plus. Here you have to compare first element if minimum value and error of I value. If error of I value is less than minimum, that's minimum is greater than error of I. That means you have to assign minimum value is error of I, then minimum index is I. If we have to compare maximum value and error of I, compare these two values. Whenever ARR of I value is greater than maximum value, maximum is less than ARR of I, then you have to assign max is equal to maximum value is equal to ARR of I, and then maximum index is equal to I. So after completion of this code, the maximum value is present in minimum value present in min variable, maximum value is present in max variable. You have to print that values. So printf /n, so minimum value is equal to %d space minimum index is equal to %d, comma minimum value is present in min, minimum index is present in min I, and then printf /n max value is equal to %d max underscore index is equal to %d, comma max index. Just save this file. Just here I am writing. So Alt F9, compilation and Control F9. First you have to debug that code. Okay, Windows watch. In this, how many variables are defined? Debug, watches, add watch. I want to show ARR. Next min, next value is max, next value is minimum index, next one is maximum index, next I value. So F7, so memory is allocated for all the variables. So this loop is repeated, so 10 times. First element is stored in this address, second element, third, fourth, fifth, sixth. Okay, so F7, enter first element. Here I am entering first element is 594. F7 9 F7 4 F7 10 8 28 10 F7 8 F7 28 F7 3 6 21 3 6 21 then 1. We have entered, so 10 elements. In these 10 elements, the minimum value is 1, minimum index is 9, maximum value is at index number 6, maximum value is 28, at index 5. Okay, so F7. So in this code, the minimum maximum value is 28 and minimum value is 1. The maximum index is 0, 1, 2, 3, 4, 5 and minimum index is 9. You have to check that values. So Windows watch. So here starting. So minimum value is, maximum value is ARR of 0. ARR of 0 value is 5. Minimum index is 0. Maximum index is 0. Minimum index. By mistake you are giving max index. By mistake here we are giving minimum index is by mistake max. Okay, no problem, minimum index is 0. First check this condition, so better to go and take minimum index is minimum index is 0 and maximum index is 0. So F7, once again first time 1, once again you enter the values 6 5 9 4 5 9 4. Next one is 10 8 28. 10 8 F7 28. Next values is 3 3 6 21. 3 6 21. Next value is 1. Okay, so 10 array elements. So F7 so minimum value is 5, maximum value is 5, minimum index is 0, maximum index is 0. First I value is 1, I value is 1, 1 less than 10, yes, condition true. Check the 5 and these two values. This condition is fail. Minimum value is 5 greater than 9, condition false. Next control, these statements are not executed. This control goes to this statement, this one. So max value is 5, 9. Max is 5 less than 9, yes, condition true. Then max value change it to 9. Look at here, max value is change it to 9 and max index is 1. This maximum index is 1. Change it to 1. Once again, next I value is 4. Now compare these two values. Minimum is 5, 5 greater than 4. Yes, condition true. These statements are executed. Minimum value is 4. These statements are executed. Minimum value is 4. 4. Minimum index is, this index is changed to 2. 2. Next max value is 9. 9 less than 4. Condition fail. These statements are not executed. Next I value is 3. So 3 less than 10. Yes, condition true. Now you have to check the minimum value 4 and 10. So 4 greater than 10. Condition false. These statements are not executed. Next 10 and 9. Max 9 less than 10. Yes, condition true. These two values, max value is 10. That's why max value changed to, we are assigning 10 to max. This max value is changed to 10 and then max index is 3. This index is changed to 3. Once again, next value is 4. I value is 4. Now you have to check it 8 with 4. So minimum is 4. 4 greater than 8. Condition fail. These statements are not executed. Next max value is 10 and 8. 10 less than 8. Condition fails. These statements are not executed. Next I value is 5. Now you have to check these values. 4. Minimum value is 4 and 28. 4 greater than 28. 4 greater than 28. Condition false. These statements are not executed. And max value is 10 and 28. 10 less than 28. As condition true. These two values, in these two values, max value is 28. This true. Then we have to assign error of I values to max. Though the max value is 28. Let's change it to 28. Then maximum index is 5. This index is changed to 5. Next 6. Minimum is 4. 4 greater than 6, 3. As condition true. then minimum value is changed to 3. Here the minimum value is 3, then minimum index is 6. The minimum index is 6. Next, this condition is failed. These statements are not executed. Next, 6 and 3 condition failed. These condition also failed. These statements are not executed. Next, 21 and 3. This condition failed. This condition also failed. These statements are not executed. Next, I value is 1. So 3, 1. 3 greater than 1. Yes, condition true. Then minimum value is 1 is assigned to minimum. If the minimum value is 1, then minimum index is 9. This value changed to 9. This one is failed. Next, I value is 10. 10 less than 10, condition falls out of the loop. After completion of the, whenever control goes out of the loop, this statement will be executed. Now the minimum value is 1. 1 is replaced here. The min space value 1 space min underscore index value is minimum index is 9. Alt F5. So min value is 1, minimum index is 9. So F7. Next, max value is 28, maximum index is 5. Alt F5. Okay. So you have to debug this code like this. Okay. So still you have to any doubts, please refer once again. Thank you for watching. Hi everybody, welcome to SMR Telugu Education. So next program is write a program to find reverse of an array. To find reverse of an array. Okay, so what is the input? Input is you have to enter one array of size 10 elements. Here I am taking array of size 10 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I am entering the elements 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. These are the array elements. Okay, so array name is ARR. First element is ARR of 0. ARR of 0. Next one is ARR of 1, ARR of 2, ARR of 3, ARR of 4, ARR of 5, ARR of 6, ARR of 7, ARR of 8, ARR of 9. So some addresses 500, 502, 500 and so on. Okay. Here the array name is array name always gives base address of an array. Array name is ARR. Now we have to find the reverse of an array. So please remember our total how many elements are there? 10 elements. Okay. So first index is how to reverse the array. Here So we are interchange these two values. Next we have to interchange these two values. Next we are interchange these two values. So we are interchange these two values. Next we are interchanged these two values. Now we get the resultant matrix is, the resultant array is first element, second, third, fourth, fifth, sixth, 7, 8, 9, 10. If the indexes is same, year of 0, here the value is 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay, so this is very simple. We have to interchange, first we have to interchange the elements of, first element is 0, error of 0, and then error of 9. We have to interchange these two values. Next error of 1, and then interchange error of 8. Next error of 2, interchange error of 7. Error of 3 can be interchanged with error of 6. Error of 4, error of 5. Okay, so now we have to interchange half of an array. So here the size of an array is 10. You have to interchange up to half. Here the index starts from, here I value is 0, 1, 2, 3, 4. The I value is 0, 1, 2, 0, 1, 2, 3, 4. Okay, we have to interchange I value 0 to 9. We have to interchange 0 and 9. 9, 8, 7, 6, 5. Okay, so please observe the logic. We have to interchange 0 and 9, 1 and 8, 2 and 7, 3 and 6, 4 and 5. Our loop is from 0 to 10 elements. You have to interchange the half of array. That means I value is starts from 1, I value is 1, I less than 5, half of an array. Array size is, array index starts from 0, I is equal to 0, I less than 5, I plus plus. Okay, so now high values are 0, 1, 2, 3, 4. We have to interchange 0 and 9. Here I am writing logic. 9 can be written as 9 minus 0. 8 can be written as, here I value is 0, then you have to interchange 0 and 9. I value is 1 and 8, you have to interchange 8. Here 9 minus 1. Here I value is 2, you have to interchange 9 minus 2. Here I value is 3, you have to interchange 9 minus 3. 9 minus 3 value is 6. Now I value is 5, you have to interchange 9 minus 4. 9 minus 4 value is 5. Now in first iteration we have to interchange error of 0 and error of 9 minus I. Here please remember, here 0, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. These values are present in which variable? I. That's why here we have to interchange I value, error of I value and error of 9 minus I value. Up to half of array we have to interchange or swap of error of 0 and error of 9 minus I. So how to swap two variables we already know. A is equal to 10, A is equal to 10, B is equal to 20. Then how to interchange A and B values? Simply A is equal to A plus B, B is equal to A minus B, A is equal to A minus B. If the A value is 10, B value is 20, A plus B value is 30. So A value is 30. Next, B is equal to A minus B. A value is 30, B value is 20. So B is equal to A minus B, 30 minus 20. Then B value is 10. Next, A is equal to A minus B. A value is 30, B value is 10. 30 minus 10. So B value is 20. Control Z. A is equal to A minus B. A value is 30 minus 10. 20 is assigned to A. So A value is 20. So just write this code. The two values are interchanged. Okay. Similarly, error of 0 is one element, error of 9 minus I is another element. How to interchange these logic? So this one is error of 0 and error of 9 minus I. this value is a, this value is b. Here a is equal to error of 0, then b is equal to error of 9 minus I. So add these two values. So add error of 0 and error of 0 plus error of 9 minus I. Add these two values and assign to another variable, either error of 0 or error of 1, your wish. Here I am assigning error of 0 is equal to, just a is equal to a plus b. So b is equal to, that means error of 9 minus I is equal to error of, instead of error of 0, we have to write error of I. Here starting I value is 0, that's why here you have to write error of I and error of 9 minus I. So error of I is equal to error of I plus error of 9 minus I, error of 9 minus I is equal to error of I minus error of 9 minus I. Error of I is equal to error of I minus error of 9 minus I. So first time, for I is equal to 0, I less than 5 as condition true, and interchange error of 0 and error of 9. These two values are interchanged. This value is 100. This value is 100. This value is 10. Next I value is increment by 1. 1 less than 5 as condition true. Swap error of 1 and error of 9 minus 1, 8. These two are swapped. This value is 90. This value is 20. Next I value is increment by 3. 3 less than, increment by 2. 2 less than 5 as condition true. Then error of 2 and error of 7. Error of 9 minus 2, value is 7. These two values are interchanged. This value is 80. This value is 30. Next I value is 3. 3 less than 5 as condition true. Error of 3 and error of 6. These two values are interchanged. This value is 70. This value is 40. Next I value is 4. 4 less than 5 as condition true. Error of 4 and error of 9 minus 4, 5. These two values are interchanged. This value is 60. This value is 70. Now I value is 5, 5 less than 5 condition false out of the loop. Now our array is interchanged 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay. Now how to convert this one into our C language code. Okay. So in this, how many variables you have to using? We have to declare a single array of size 10 elements. We have to scan that values and declare one variable I for loop purpose and write this logic inside this loop. Okay. Now we are converting. Alt F new F2, file name is reverse.c F5. Here I am using void main. So how to declare array? Into array of array size is 10. We have to scan that values and loop purpose we are using I clr scr to clear the screen. So printf, ask the end user to enter the array elements. Enter 10 array elements and scan the value. For I is equal to 0, I less than 10, I plus plus. So ask the end user enter the first element. So slash n enter percentage d element. Comma I plus 1. So enter first element and scan the values. Scan a percentage d comma address of error of I. Okay. So by using pointers concept directly, instead of writing address of I, we have to write another way. We will write later. Okay. Now we have to write the logic for swapping of reverse the array. Okay. We have to start from 0 to half of an array. We have to interchange the first element into last element. Okay. Here the last element is 9. That's why here I am writing 9 minus I. Sometimes last element is 9. Then you have to write n. Then you have to write n minus 1. That's okay. So for we have to interchange from 0 to I less than 5, I plus plus. So interchange logic, error of I is equal to error of I plus error of 9 minus I. Then you have to assign error of 9 minus I is equal to error of I minus error of 9 minus I. So error of I is equal to error of I minus error of 9 minus I. This is the swapping logic, swapping of two numbers. Okay. So after execution of this code, you have to print the array. So printf, I am giving one message. So array after swapping, after reversions. Give slash n array after reverse. Okay. So for I is equal to 0, I less than 5, I plus plus and print the values. So printf percentage d comma error of I. So save this file F7. Yes. So our execution is always starts from main function. So remove all watches and then add error. Okay. So if memory is allocated for 10 elements, here also I am writing I value I initial value is garbage value. Printf enter 10 elements. First element I am entering 10. This loop is repeated 10 times. 1, second time 20, third time 30, fourth time 40, fifth time 50, 60, 70, 80, 90, 100. So this loop is repeated 10 times. I value is 10, condition false, then control goes to out of the loop. Now enter elements are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I value is 10. Okay. Now I value is 0. 0 less than 5. As condition true. F7. Here ARR of 0 and ARR of 9. These two values are interchanged. 9, 10 plus 100. 110 is assigned to ARR of I. 110. Next 110 minus 100. Value is assigned to this one. 10 is assigned here. Next 110 minus 10. 100 is assigned here. These two values are interchanged. This is the next I value is 1. 1 less than 5 as condition true. Once again these two values are interchanged. 20 and 90. 110. This value is 90. This value is 20. Next these two values are interchanged. 30, 80. Next fourth time these two values are interchanged. 40, 70. Next 4 less than 5 true. Next these two values are interchanged. 110, 50, 60. Next I value is 5, 5 less than 5. Condition false, out of the loop. Next this statement is executed after array after reverse alt F5. This is message. Next I is equal to 0, 0 less than 10, condition true. Here I value is 0, 0 less than 10, condition true. ARR of 0, 100, alt F5, 100 is printed. Next I value is 2, I value is 1, ARR of 1, 90, alt F5, 90. Next I value is 2, ARR of 2, 80, I value is 3, 70, alt F5, 70. Next I value is 4, 60, alt F5, 60. Next I value is 50, 40, 30, 20, 10. Next I value is 10, 10 less than 10, condition false, out of the loop. Okay. So better to give some space here. So F2, yes. So alt F9, yes, control F9. Enter 10 array elements. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So alt F5, output is array after reverse 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay. So still you have any doubts? Please repeat once. Thank you for watching. Hello everybody. Welcome to SMR Telugu Education. So next topic is sorting the data. So bubble sort. Bubble sort. So arrange the data in sorting order. Okay. Here I am taking the array of size 6 elements. First element, next element, next, 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 next. So total 6 elements are there. First element is 6, next element is 3, next element is 10, 5, 28 and 1. These are the array elements. You have to arrange these elements in sorting order. Every array has some name. First element is ARR of 0, ARR of 1, ARR of 2, ARR of 3, ARR of 4, ARR of 5. Here first index starts from 0 to n minus 1. Here I am taking the base addresses, some address 500, 502, 504, 506, 508, 508. Okay. So how to arrange these elements in a sorting order? So bubble sort follow some algorithm. You have to follow the same thing. First you have to compare first element and second element. You have to compare these two. You have to compare these two values. Next you have to compare these two values. Next you have to compare 6 and 10. Next you have to compare. So in bubble sort, first you have to fix the first element. First element. In bubble sort, sorting is from right to left. Sorting is from first in first pass. Here there is a word called iteration or pass. First iteration or first pass. The highest element is shifted to ARR of 5. So what is the highest element in the array is 28. This 28 is in first pass or first iteration. The highest number is shifted to ARR of 5. In first pass, you have to compare this value into this value. We have to compare these two values. If this value 6 is greater than 3, this value is greater than this one, then you have to shift these two values. Okay, this is the first comparison. Next you have to compare these two values. If this value is greater than this one, you have to shift these two values. Next you have to compare this value into this one. If this one is greater than this one, then you have to interchange these two values. Next one, you have to compare this value into this thing. If this value is greater than this one, you have to shift these two values. Next you have to compare this number into this value, then you have to shift this value is greater than this one, you have to shift these two values. In pass 1, how many comparisons are there? This is first comparison, this one is second one, next one is third, next one is 4 and 5. In first pass, number of comparisons is 5. So number of comparisons is 5. So in first pass, which one is the highest element is shifted to error of 5. First you have to compare this element error of 0 and error of 1. First here you have to compare error of 0 is greater than error of 1. Here I am comparing 0 and 1. Then you have to shift these two values. In this case the condition is true, then you have to shift error of 0 and error of 1. Here I am shifting these two values. Here the value is 3, here the value is 6. Next you have to compare error of 1 and error of 2. We have to compare these two values. If error of 1 is greater than error of 2, then you have to shift these two values. Error of 1 is 6 is greater than 10, so condition fail. Then next you have to compare error of 2 and error of 3. Next you have to compare error of 2 and error of 3. If error of 2 is greater than error of 3, then you have to shift these two values. Error of 2 is 10 is greater than 5. Yes, condition true. Then you have to shift this value is 10, then this value is 5. Next you have to compare error of 3 and error of 4. Error of 3 is greater than error of 4, then this condition is true. Error of 3 is 10 and error of 4 is 28. If this condition is true, then you have to shift these two values. So this condition is failed. Next you have to compare error of 4 and error of 5. Next you have to error of 4 and error of 5. You have to compare these two values is greater than, so this condition is true. Error of 4 is 28, error of 5 is 1. Then you have to shift these two values. This value is 1, this value is 28. So after completion of the first pass, the which element is the highest element is come to the last. Okay, now in this first iteration or first pass, how many comparisons total? This is 1, 2, 3, 4, 5. So total how many comparisons in first pass? Total 5 comparisons are there. Okay, now after completion of the first pass, the elements are in this position. This one is 5, this one is 10, 1, 28, 3, 6. Okay, next in second pass, in second iteration, in iteration 2, in second pass you have to compare error of 0, error of 0 and error of 1. If error of 0 is greater than error of 1, then you have to shift these two values. This condition is failed. Then you have to compare with error of 1 is greater than error of 2. If this condition is true, then you have to shift these two values. This value is 5, this value is 6. Next one, you have to compare error of 2 is greater than error of 3. So error of 2 is greater than error of 3. This condition is failed. Next you have to compare error of 3 and error of 4. So error of 3 is greater than error of 4. Here error of 3 is 10 is greater than 1. Yes, condition true. Then you have to shift this value is 1, this value is 10. This is second pass. In second pass, total how many comparisons are there? Total 4 comparisons. First time total number of comparisons is 5. Now the number of comparisons are 4. This is the first pass. Our index value I is starts from 0. This is I will take, this one is pass 0. I value is 0. This one is I value is 1. So after completion of the 2 passes, this is the first iteration. The highest value is goes to last place. In second pass, next highest is goes to error of 4. In third pass, we have to compare error of 0 and error of 1. If error of 0 is greater than error of 1, then you have to shift these two values. This one is failed. Next you have to check error of 1 is greater than error of 2. So error of 1 is 5 is greater than 6. Condition failed. Next you have to check error of 2 and error of 3. Error of 2 is 6 is greater than 1. Yes, condition true. You have to shift these two values. So shift these two values. Here the value is 6. This is the value is 1. So in pass 3, number of comparisons is, here the number of comparisons is 3. Next, this is the second pass. In pass 3, first you have to, after completion of the third pass, third iteration, the third highest values comes to third place. Next one is in fourth pass, we have to compare error of 0, error of 0 and error of 1. Error of 0 is greater than error of 1, then you have to shift these two values. Error of 3 is greater than 1, condition false. Next one, you have to check error of 1 and error of 2. If error of 1 is 6 is greater than 1, yes, condition true, then you have to shift these two values. This value is 1, this value is 5. So in fourth pass, how many comparisons are there? 2 comparisons. 2 comparisons. In fifth pass, you have to compare error of 0 and error of 1. If error of 0 is greater than error of 1, this condition is true, then you have to shift these two values. Error of 0 is 3 is greater than error of 1, yes, condition true, then you have to shift these two values. So this value is 3, this value is 1. Here the number of comparisons is 1. See, please observe, here the number of the array size is 6, then number of passes is 0, 1, 2, 3, 4. That means 5 passes or 5 iterations. That means the I value is 0, 1, 2, 3, 4, 4. That means the number of passes is 5 passes. If the size is n, then number of passes is n minus 1. So last element, only a single element, there is no comparisons. Okay. If I is equal to 0, then you have to compare. So how many comparisons? 5 comparisons. In first iteration, you have to total how many comparisons? 5 comparisons. Here you have to compare from 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5. That means here I am taking the starting value is 0. Here the starting value is 0. We are comparing with 1. Next value is 1. We are comparing with 2. Here I take the starting value is fixed 0, 1, 2, 3, 4. Here also the starting value is 0, 1, 2, 3. Starting value is fixed 0. Here also starting value is 0, 1, 2. The starting value is fixed. Here also the starting value is 0, 1. The starting value is fixed. Here the starting value is 0. So in each iteration the starting value is fixed. So how to convert this one into code? So first outer loop is starting value is fixed. So starting value is 0. So last value is fixed or not? We don't know last value, leave it. I is equal to I plus 1. This is the outer loop. Here the array size is take array size is n. Here array size is 6. If array size is 6, then here the number of passes is 0, 1, 2, 3, 4. That means here you have to write 0 to 5. 5 means less than n minus 1. Then you have to, this loop is repeated how many number of times? 0 to n is 5. Then I value is g 0, 1, 2, 3, 4. Okay, next. Here the comparisons, each comparison, first 0, second comparison also 0, next also 0, next also 0, 0. So in this starting value is fixed. Here I am taking another inner loop. So j is equal to 0, starting value is fixed, j less than or equal to, every time j is incremented by 1, j is equal to j plus 1. Here we are comparing with, here we are comparing 0 and 1, 1 and 2, 2 and 3. Here we are comparing j value is incremented by every time 1. That's why here I am incrementing j value is 1. Here you have to think about what is the last value. So this inner loop is repeated fixed number of times or variable number of times. So this inner loop is repeated. First how many number of times loop is repeated? 5 times. Second time how many comparisons? 4. Next time how many comparisons? 3. Next time 2. Next time 1. Okay. Now here the value of n is, so value of n is 6. This is the I value is 0, 1, 2, 3, 4, 5. How to get 5, 4, 3, 2, 1? So here the last value is variable value. First year we are writing, no need to write r equal to, I am writing less than, array is always less than, 0 to less than. Here total how many comparisons? 5 comparisons. That means here you have to write, what is the value? Starting you have to write 5. Then this loop is repeated 5 times. Next time here you have to write 4. Next time this loop is repeated, so 3 times. Here you have to write 3. Next time 2. Next time 1. That means the inner loop is repeated variable number of times. That means here we have to write some variable value. First here the j is repeated how many number of times? First j is repeated. First how many? First you have to write 5. Then this loop is repeated 5 times. Next time is 4. Then this loop is repeated 4 times. Next 3. Next time 2. 2 times. Next time 1. Next time 1. 1 time. Now here you have to write some variable. Now here we are comparing error of 0 with error of 1. Here we are comparing error of 0 and error of 1. That means error of j. How to get 1? We have to add plus 1. Error of j and error of j plus 1. Here j value is 1. We are comparing with next element j plus 1. Here the j value is 2. We are comparing with 3 j plus 1. Here we are comparing error of j and error of j plus 1. If error of j is greater than error of j plus 1, then you have to interchange the values. Here I am checking the condition. If error of j is greater than error of j plus 1, then interchange error of j and error of j plus 1. Swapping of two values. We already know how to swap these two values. Okay. Now what is the condition here you have to write? Here first you have to write 5. Next time first you have to write 5. Next time is 4. Next time is 3. Next time is 2. Next time is 1. How to write these values? Here, so what is the value of first? How to get 5, 4, 3, 2, 1? Here the n value is 6. I value is 1. Next 6, second iteration 6, 1. Next one is 6, 2. Next one is 6, 3. Next one is 6, 4. Here I am writing n minus I. Value is 6. N minus I 5. Here the n minus I value is n minus I value is 6, 5, 4, 3, 2. This is the n minus I value. But how to get 5, 4, 3, 2, 1? Decrease one value minus 1, minus 1, minus 1, minus 1, minus 1. Here you have to write n minus I minus 1. So starting value I is in first pass I is equal to 0, I less than 5, condition true. Then this loop is repeated how many number of times? 5 times. This is first. This is the first comparison. This is the second. This is the third. This is the fourth. This is the fifth. If the condition is true, then they are interchanged. After completion of the first pass, the highest values goes to the last position. In second pass, number of comparisons is 4. Then highest values goes to next place. Now how to convert this one into code? In this program, how many variables are using? N, the size of array, next I and j. Alt F, new, F5, F2, save. File name is some name .c, void main. Okay, so here declaring array of size. Our wish, here I am taking array size is 6, or if you want you can scan n value from the user. Array size is 6 and scan the array values I for I and j. Clear the screen. Ask the end user to enter the values. Enter array elements. For I is equal to 0, I less than 6. Here I am writing fixed 6 values I plus plus. Here printf /n, enter %d element, comma I plus 1. So enter first element, second element, some message and scan the values. Here I am using address of ARR of I, or if you want you can directly write ARR plus I by using pointers. Okay, we have to scan the values. Next you have to write the logic for swapping, logic for bubble sort. First, number of passes is n minus 1, that means total number of passes 5. For how to convert this one into code. This is the outer loop. In this outer loop, this is the initialization, this is the condition, this is the iteration. So in this outer loop, you have to write once again the inner loop. This is initialization for I is equal to 0, condition I less than 6 minus 1, that means 5, I plus plus. So in this outer loop, once again you have to write the loop. J is equal to 0, J less than, here the condition is n minus I minus 1, J plus plus. Here we are comparing f j and f j plus 1. If error of j, that means error of 0 and 1, 1 and 2, 2 and 3, 3 and 4. Error of j is greater than error of j plus 1. Then interchange these two values. Error of j is equal to error of j plus error of j plus 1. Error of j plus 1 is equal to error of j minus error of j plus 1. Here error of j is equal to, this is the interchanging logic. We already know how to interchange two variables a and b. A is equal to 10, b is equal to 20. How to interchange? Same logic. Printf array elements are /n. Okay, so for I is equal to 0, I less than 6, I plus plus, and printf %d, I am giving space, comma error of I. So F7, instead of n, here size is 6 minus I minus 1. So F7, Windows, watch. Here I am adding error and then I and j values. I j and j plus 1 also, j plus 1. So our execution always starts from main function. Memory is allocated for 6 elements. So enter array elements. First enter 6, next 3, next we are enter 10, next one is 5, next one is 28, next one is 1. These are the 6 array elements. So please observe, this is the first pass. I is equal to 0, I is equal first in first pass, so j value is 0. Here total how many comparisons? 5 comparisons. A are of 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5, total 5 comparisons. First j value is 0, j plus 1, both error of 0 and error of 1. This condition true or false? True. This code is executed. These two are interchanged. 3 is in error of 0 and 6 is in error of 1. Yes, these two are interchanged. Next, j value is increment by 1, error of 1 and error of 2, condition failed. Next, error of 2 and error of 2 and 3, yes, this condition is true. Then these two are interchanged. These two are 5 here, 5, 15, 5 and 10. Next, 3 and 4, this condition is failed. This code is not executed. Next, 4 and 5, this condition is true. Then 28 is here and 1, these two are interchanged. 28 and 1. See, first pass, what is the highest element is? Sorting is from right to left. In first pass, highest element is in last position. Next I value is 1. Next in second pass, next second highest is in the second place. Yes, true. Error of 0 and 1, this is failed. Next, compare these two values. True. These two are interchanged. Yes. Next, these two, condition failed. Next, 10, 1, this condition is true. These two are interchanged. 10 and 1. In second pass is completed. I is equal to 1 is completed. In this, second highest value is in second position. In third pass, I is equal to 2. Once again, third highest is come to this place. Comparison from 0 to error of 0 and error of 1. That's why j is equal to 0. This condition is j and j plus 1 fail. Next, these two. Error of 0, 1 is greater than error of 2. Condition failed. Next, 6, 1. Yes, condition true. Then these statements are executed. These two values are interchanged. Yes. Next, so third pass is completed. Third iteration is completed. Third element is goes to third position. So in bubble sort, sorting is from right to left. Next pass, these two condition failed. Next, these two condition true. These two are interchanged. 5 is here, 1 is here. Next, I is equal to 4. These two are interchanged. Check the condition. Yes, true. These two are interchanged. Yes. Next, I value is 5. 5 less than 5. Condition pass out of the loop. Next, this statement is executed. Array elements are Alt F5. Array elements are F7. First element is So F7, so first element is 1, next second element is 3, F7 next element is 5, F7 next element is 6, F7 Alt F5 10, F7 Alt F5 28, F7 memory is deallocated. So this is the bubble sort. Here the number of passes is 1 to n minus 1. So how to write this code? By using pointers concept. Without using, similarly how to write, without writing address, simply how to write ARR plus I. Here also at the time of printing also, this can be also written as asterisk ARR plus 1. Both are same. I. Alt F9, yes, Control F9. First element is 3, 6, 2, 8, 10, 1. So Alt F5, same 1, 2, 3, 6, 8, 10. Okay, this is bubble sort. So please debug and write step by step. It is at the first time it is very difficult to understand. Okay. So still you have any doubts, please repeat once again. Thank you for watching. Hi everybody, welcome to SMR Telugu Education. Next topic is multi-dimensional arrays. Multi-dimensional arrays. First we have to discuss about 2D arrays. So two-dimensional arrays. So is nothing but array of arrays. So you already know the array name always gives base address of an array. What is the meaning of ARR of int ARR of 3? So what is the meaning of int ARR of 3? Here array ARR is the name of the array. Array name always gives base address of an array. Here the memory is allocated for 3 elements. First element is ARR of 0, next element is ARR of 1, next element is ARR of 2. ARR of 0, ARR of 1, ARR of 2. The base address is, here I am taking base address is 500, next address is 502, next address is 504. Here the default values is, here garbage value of which type of variable? Integer. Here the default value of an integer is stored here. Okay. Next, what is the meaning of two-dimensional arrays? Here we are declaring int number of rows and number of columns. Here the meaning is int ARR of 3, 4. Here this semicolon. This is the number of rows. This one is number of rows. This one is number of columns. Rows and columns. Here first ARR of 3. What is the meaning of int ARR of 3? Here the memory is allocated for 3 variables. So first ARR of first element is ARR of 0, next ARR of 1 and ARR of, the first element is ARR of 0, ARR of 1, ARR of 2. ARR of 1, ARR of 2. Here ARR always gives base address of an array. Here the array name ARR always gives base address of an array. ARR always gives base address of an array. Similarly, ARR of 0, ARR of 1 and ARR of 2 are also arrays. This is called array name. Array name always ARR always gives base address of an array. Here array of arrays. Array of arrays. Here ARR of 0 is one array. ARR of 0 is one array. ARR of 1 is another array, and ARR of 2 is another array. Each array has number of columns. How many columns? 4 columns. Once again, ARR of 0 has 4 columns. First one is 0, 1, 2. Similarly, ARR of 1 is also 4, ARR of 0, ARR of 1, ARR of 2, ARR of 3. Similarly, ARR of 2 also an array. The array has 4 columns. First, second, then third. If the base address is, so please remember here ARR always gives base address of an array. Here I am taking the base address is 500. The base address is 500. Next, ARR of 0 has how many elements? 1, 2. Here I am also giving the index. The index is 0, 1, 2, 3. So this one is ARR of 0, 0. ARR of 0, 0, 0. So next one is ARR of 0, 1. Next element is ARR of 0, then 2. Next element is ARR of 0 and 3. Similarly, this element is also 1 0, 1 1, 1 2, 1 3. ARR of 2 0, 2 1, 2 2, 2 3. Here the memory is allocated for total how many? Here the array name is ARR. Here the memory is allocated total how many elements? So 12 elements. First one is this one. Here I am taking the base address is 500. Array name ARR of 0 gives the base address of an array 500. ARR of 1 address is this one. This address is 500. Next value address is 502. Next address is 504. Next address is 506. Five not two, 504, and then 506. Next element address is in C language the memory is allocated continuously. Here ARR of 0 address is 500. Here ARR of 0 value is equal to 500. So what is ARR of 1 is equal to, this is the address of ARR of 1. In after memory is allocated for first 4 elements, then the memory is allocated for this one. This is the address of ARR of 10. This one is 11. This one is 12. ARR of 12. ARR of 13. This is 11. This is 12. So 10 address is 508, 11 address is 510, 512, 514. Next, continuously this address is 20, 21, 22, 23. This address is 516, 518, 520, then 522. This is the continuous memory is allocated. Continuous memory is allocated. AR of 1 base address is this one, 508. 508. So what is the base address of ARR of 2? ARR of 2 is 516. So this address is this one. So ARR of 0 is 500. ARR of 0 is 500. ARR of 1 is 508. ARR of 2 is 516. So the continuous memory is allocated. This one is ARR of 0. So what is the value of ARR? Array name always gives base address of an array. This base address of an array is array name always gives base address of array. This array base address is 500. This value is 500. Next. So what is the address of first element? First element address is, what is the ARR of 00 is the value. ARR of 00 is the value. These values are initial values is garbage values. This one is garbage value. This one is garbage value. So garbage value and so on. Every element has garbage value. So 00 is garbage value. So what is the value of address of ARR of 0 and ARR of 0? This variable address is 500 is equal to 500. Here the ARR of 00 is this element. This element address is this one. The base address is 500. Please observe, here ARR also 500. ARR of 0 is 500. Address of ARR of 00 is also 500. All are representing the same value, that is the base address of an array. So here I am incrementing ARR 0. ARR of 0. First I want to execute this code. F2 file name is 2d.c. So void main int ARR of number of rows, number of columns. Clear the screen and then print the printing base address of an array slash n percentage u percentage u percentage u. Array name is always this base address of an array. Error of 0 is also base address of an array, and address of error of 0 and 0 is also the base address of an array. All are same. So run this code. Alt F9, yes, Control F9, Alt F5. So base address is 65,502, 502, 502. Okay. So whenever I am incrementing, printf slash n percentage u. Here we are incrementing error of 0 plus 1. Error of 0 is this address. We are incrementing one value. That means we are adding these 4 elements. This one is pointing to error of 1. This value is equal to error of 1. So now what is the value of error? Error is equal to 500. So we are adding error plus 1. Error plus 0. What is the meaning of error plus 0? This values are also we can written as error of 0. Both are same. So what is the error of plus 1? We are adding error of plus 1 means we are adding array name is error. We are adding plus 1 means we are adding total how many elements? 4 elements. That means we are adding plus 1 means this array is pointing to the next element. The next element is error of 1. So this value is equal to error of 1. So in pointers concept we already discussed error of 1 can be written as error plus 1. Both are same. This one and this one both are same. This value is equal to error of 1. Error of 1 value is equal to 508. 508. So whenever I am adding error plus 2 means this value is equal to error of 2. So error of 2 value is equal to 516. This value is equal to 516. So percentage u, comma error value is base address 65,502. Whenever we are adding plus 1, it is pointing to the error of 1. That means plus 8 bytes is added. Error of plus 2 means this value is equal to error of 2. All are same. Run this code Alt F9 and Control F9, Alt F5. 65,502, 510, 518. That means whenever we are adding plus 1, it is added to how many elements? 4, 4 and 4. Each time 4 elements are added. Here error of 0 is also an array. Whenever we are adding error of 0 plus 1, then it is pointing to the next address, next element. That means here error size, error of 0 size is, this array size is 4. This array number of columns is 4. That's why whenever we are adding error of 0, whenever we are adding plus 1 means it is pointing to the next location. It is pointing to the next location. That is value is 502. So this value is equal to 502. So we also write this value error of 502. So what is the value of So error of 0 plus 2 means it is pointing to the next location. Plus 2 means it is pointing to we are incrementing two values 504. We are adding one more plus 1 means pointing to the next location. That means this value is equal to 504 printf /n %u %u. Here I am adding error of 0 means base at first this address 500. Whenever we are adding plus 1 means 502. That means ikkada alt F5 65,502 next address 65,504 and these two are garbage values. Run this code semicolon. Run this code. Value is alt F5 65,504. Whenever we are adding error of 0 plus 1 plus 2, it is pointing to the next element. Error of 0 plus 3 this value is equal to error of 1. This is called alt F5 504 506 508. Run this code. Continuous addresses 504 506 508. So error of 0 0. This gives the value, that is garbage value. What is the address of error of 0 and 0? This gives the address is 500. Now what is the value of error of 2 plus 1? So what is the value of error of 2 plus 1? So here error of 2 is error of 2 value is 516. Whenever we are adding plus 1, this is pointing to the next address. That means this value is equal to 518. Now what is the value of error of 1 plus 2? Here error of 1 means this address 508 508 we are adding plus 2 means this is pointing to the next address. So this value is equal to 518. Error of 1 plus 1, this value 5 plus 2, this value is equal to 510. Okay, so please remember, two-dimensional array means array of array. This is one array, this is one array, this is one array, this is one array. Single array. Whenever we are adding error of 0 plus 1, it is pointing to this address. Whenever we are adding plus 2, this is pointing to this address. Whenever we are adding plus 3, pointing to this address. This is the two dimensional array of arrays. Okay. Now here I am printing the address of error of 0, comma error of 1, comma error of 2. Comment this code. +8 +8 +8. Save. Alt F9. We are missing parenthesis. Run this one. Alt F5. +8 +8 +8. Now error of 0 is address, error of 1 is address, error of 2 is address. Error of 0 plus 1 is an address, error of 0 plus 2 is an address, error of 0 plus 3 is address, error of 0 plus 3 is address. Error of 0 0 is a value, 0 1 is value, 0 2 0 3, 1 0 1 1 1 2 1 3 values, 2 0 2 1 2 2 2 3. These are the values. So total how many elements? The memory is allocated for total how many elements? So 12 elements continuously. Here just I am printing the values. Debug this code. F7 Windows watch debug add watch. Here I am taking error. Array name is error. F7. Yes, memory is allocated for total. This one error of 0. This one is error of 1. This one is error of 3. So 3 arrays. Array of arrays. Total 1 array. Within this is single. Error of 0 is this address. Error of 1 is this address. Error of 2 is this address. Error of 0 plus 1 means pointing to only this address. Error of 0 plus 2 means pointing to this address. Error of 0 plus 3 means pointing to this address. Error of 1 means this address. Error of 1 plus 1 means this address. Error of 1 plus 2 means this address. Error of 1 plus 3 means this address. Error of 2 is this base address. Error of 2 plus 1 this address. So error of 2 plus 1 plus 2 means this address, plus 3 means this address. The continuous memory is allocated for two dimensional arrays. Next, how to initialize the arrays. Int error of some size 5 is equal to single dimensional array 1 2 3 4 5. Next, int error of number of rows 2, number of columns 3. Total how many elements? 6 elements are allowed. This is the array. This is this is an array. Within the array we have how many single dimensional arrays? 2. This one is 1. This one is another one. So first row, how many columns? 3 columns. 1 2 3 and then 4 5 6. Total how many elements? 6 elements. Okay, this is the array initialization of two dimensional arrays. By mistake sometimes you have to declare like this: int array of 2 and then 3 is equal to 1 2 3 4 5 6 semicolon. This is also valid. These values are allocated continuously. This is array of 0 0 0 1 0 2 1 0 1 1 1 2. Continuous memory is allocated. Okay. Next, int error of number of rows 3, number of columns 4. This can be initialized by using so this is first row, second row, then third row. First column, total number of columns is 4. 1, 2, 3, 4 valid. By mistake if we give 5, we will get an error. This is, we will get an error. So if you want, you can give 0 and then 1. Remaining elements are 0. This one is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. This one is 1, 0, 1, 1, 1, 2, 1, 3. If you want to run this code, we will get an error because of we are giving 5 extra here. Okay. This is array initialization. This is just a two-dimensional array. How to declare and how to access the elements. What is the difference of AR of 0, AR of 1 and AR of 2? What is the AR of 0 plus 1, 1, AR of 1 plus 0 plus 1 plus 2. Okay. Still you have any doubts? Please repeat once again. Thank you for watching. Hi everybody, welcome to SMR Telugu Education. In this video we will discuss about how 2D array are present in memory. Here we are declaring int AR of 3 and 4. 3 and 4. So array of arrays is 2D arrays. Here number of rows is 3. So the memory is allocated for total how many elements? So 12 elements. Continuous memory is allocated. So first one is AR of 0. This one is AR of 0. This one is AR of 1, AR of 2. This is the number of rows. So AR of 0, AR of 1, AR of 2. Here I am taking base address is 500. So what is AR of 1? AR of 1 is 508. 508. Next address is plus 8. 516. 516. So in array of arrays, in AR of 0 is one dimensional array. In AR of 0 we have total how many columns? 4 columns. So this can be divided into, this is the first element, second element, third element, and then fourth. Similarly AR of 1 is also divided into first element 1 0 1 1 1 1 1 2. Next 2 0 2 1 2 1 2 2 2 3. Here I am writing the indexes 0 1 2 2 3. 0 0 0 0 1 0 2 0 3. Similarly 1 0, this element is 1 0 1 1 1 2 1 3. Similarly this element is 2 0 2 1 2 2 2 3. So what is the error of 0? Error of, what is the error? Error is base address of an array. Base address is 500. So what is error of 0? This one is error of 0. This one is error of 2. This one is error of 1. So what is error of 0? Error of 0 is 500. So what is error of 1? Error of 1 is 508. So error of 2 value is 516. So what is error plus 1 means? Error is pointing to this address, base address of an array. Whenever we are incrementing one value, error is pointing to this value, this array, error of 1. That means this value is equal to 508. So whenever I am adding error plus 2 means this value is, we are adding plus 2 means this is plus 1 is pointing to this location, plus 2 means pointing to this location. This value is 516. So what is error of 0? Error of 0 is 500. Here I am adding error of 0 plus 1 means we are adding one value to this array. That means this one is pointing to this address. That means this value is 502. So this address is 502. So error of 0 plus 2 means 504, 506. Error 0 plus 1 means 504. Error of 0 plus 2 means 506. Error of 0 plus 3 means plus 1 means 502, plus 2 means 504, plus 3 means 506, plus 4 means 508. Indirectly this is this value is 10. Next, error of 1 means error of 1. This value is equal to 508. Error of 1 plus 1 means this one is pointing to next location, 5, 10. So Please remember, this is the integer pointer. Whenever we are incrementing one value, this is pointing to next address. The next address is this one. Next address is this one. Whenever we incrementing plus 2, this is pointing to this address. Whenever we are incrementing plus 3, it is pointing to this address. So this value is 510, this value is 512, 514, 516. Next, ARR of 2 is ARR of 2 value is equal to 516. So ARR of 2 plus 1 means pointing to next address. 518, this address 518, 520, 522. So the continuous memory is allocated. So in memory, how they are present, this is the ARR is the single array. In this single array, how many arrays? First array, second array, third array. In memory, it is showing this is within the array, single dimensional array, single dimensional array, single dimensional array. In each single dimensional array, 4 garbage values, 1 2 3 4, some garbage values. So 1 2 3 4, some garbage values, 1 2 3 4, some garbage values. So this is 2D arrays present in memory. Okay. Hi everybody, welcome to SMR Telugu Education. Next one is multi-dimensional arrays, how they are present in memory. Here I am declaring array int ARR of multi-dimensional arrays. So this is number of rows, this one is number of columns, this one is number of blocks. So array of array, this one is blocks, this one is rows, this one is columns. So in each block, total how many elements? So 20 elements. This is the block 0, block 1, and then block 2. Zero block. This is index starts from 0. That's why this is 0 block. First block, second block, first block, second block. So each block, that means this is ARR of 0, this is ARR of 0, this is ARR of 1, this is ARR of 2. So in ARR of 0, it contains number of rows and number of columns. Total how many elements? 20 elements. Number of rows, number of rows, zero, 1, 2, 3. Similarly, 0, 1, 2, 3. Zero, 1, 2, 3. So this is the rows. Each row can contain number of columns. How many columns? 5 columns. So first, second, third, fourth, and then fifth. Here the indexes is 0th index 1, 2, 3, 4. Similarly 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So 23rd element is present in which location? 23rd element. 23rd element is present in which location? This one is 20 elements. These are completed. These are These are 20 elements is completed. 23rd element is present in this location. First, second, third. It's better to take dots. First element, second element, third element. This location. First element, increase brush size. First element, second element, third element, fourth element, fifth element. First, second, third, fourth, fifth. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For total 20 elements. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 20. Here also 20. So 23rd element is present in which location? 23rd element. 20 is completed. Next you have to write 23rd element is this one. How to write? The array indexes which is present in error of 1, and then number of rows. Which row? 0th row. And number of column. Second column 0, 1, 3, 0, 1, 2. Second column. This is the 23 is present in this array index. So what is the value of 32? So 20 is present, 20 is completed, 10, 20, 30 is completed. Next value is 32 is this location. So this one is present in which block? Error of 0, error of 1. Next, number of rows 0, 1, second row, number of column second, that means 1. Here the third row, second column. This is the 32 index. 32 element is present in this array index. Okay. Next, what is the value? What is the array index of 56 element? 56th element is present in which location? 40 completed, 50, 55, 56. 56 is this location. this value. This value is present in which block? Second block. Which row? Third row, and then first column. This one. Now how these values are present in memory? One more thing, what is ARR? What is ARR? ARR always gives base address of an array. Here I am taking base address is 500. So what is, whenever we are incrementing ARR plus 1 means we are adding the block. We are adding this block. That means ARR of 1 is pointing to this block. So this is total how many elements? 20 elements. Each size, integer size is 2 bytes. So this value is equal to 540. So better to take error of 0, error of 0, error of 1, error of 0, error of 1, and then error of 2. Here error of 0 is base address of array 500. If the base address is 500, next address is 20 elements means next block address is 540. Next block address is 580. So error of 0 is 500. What is error? Error is 500. So whenever we are adding error plus 1 means it is pointing to, we are adding plus 1 means this is pointing to next block. That means this value is equal to 540. So whenever I am incrementing 2, ARR plus 2 means this one is pointing to, plus 1 means pointing to this address, plus 2 means pointing to this address. So this value is equal to 580. Now every block error of 0 can contain number of rows and number of columns. Once again, this error of 0 can contain number of rows 4, number of rows, first row, second, and then third. Similarly, error of 1 can contain number of rows, first row, second row, third. Similarly, first row, second, third, fourth. Here error of 0 is block. Whenever we are adding, error of 0 is array of arrays. Once again, this is one array, this is another array. ARR of 0, 0. ARR of 0 and 0 is also an array. This is also array. Array name always gives base address 500. ARR of 0, 1, 1, 0 is also base address of ARR of 0, 540. ARR of 2 is one block and this is also array 580. These are also base addresses. So ARR of 0, 0 is a array. Whenever I am adding ARR of 0 plus 1, here error of 0 is block. Whenever we are adding plus 1 means we are adding 5 elements. That means this value is 510. Next plus 2 means this is, we are adding plus 1 means 510, 520, then 530, here error of 0 is block, error of 0 0 is a row. Whenever I am adding row, one value means plus 1 means pointing to next row. First row is 500. Error of 0 is block. Whenever I am adding plus 1 means it is pointing to the next row, that is 510. Error of 0 is a block. Whenever I am adding 2, that means it is an array, it is pointing to next row 520. Plus 3 means 530. Similarly, error of 1 is block. This is block. Whenever I am adding 1 is block. Whenever I am adding plus 1s, this is block. This is also an array, error of 1 and 0. Whenever I am adding plus 1 means we are adding how many elements? This 5 elements. That means I am adding plus 1 means this is pointing to this address. I am adding plus 2 means I am incrementing by another next address. Incrementing, I am adding plus 1 means it is pointing to next one. So this value is equal to 550. So what is the value of error of 0 and then 0. Error of 0 0 is this address. Error of 0 0 means this is an array. Array I am adding plus 1 means this is pointing to next address. That means 502. Error of 0 0 0 means the element, that element is garbage value. The address of error of 0 0 0, this is called base address 500. Now this is called array of arrays. Error of 0 is block. Error of 0 0 is an array. Error of 0 0 is an array. Error of 1 0 is a two-dimensional array. Error of 2 0 is another array. Whenever we are adding plus 1 to array, it is pointing to next location. Now tell what is error of 2 plus 1. So what is the value of error of 2 plus 1? What is error of 2? Error of 2 is block. That block starting value is 580. Whenever we are adding plus 1 means this is another array of size error of 2. Error of 2 is this block. Whenever I am adding plus 1 means here we are adding this row. That means in row contain how many elements? 5 elements. 5 integer values. Integer size is 2 bytes. That's why it is increment by 10. That means this one is pointing to this address, first address. Plus 10, this value is equal to 590. Next, what is the value of error of 2? One plus 1. Here error of 2 is block is 0 0 1 2 3 and then 4. Once again each row 2 1, second block first row, this is the first row. This is an array. 2 1 is a 2-dimensional array. Whenever we are adding, this address is next. This address is 590. Next one is 600. Next one is 610. Next one is 620. Five 590, 600, 610. Here error of 2 1. Error of 2 is block. 1 means this row. This row can contains how many columns? 5 columns. 1 1 2 3 4 5. Here error of 2 1 means this address. We are adding plus 1 means it is pointing to next address. That means that value is equal to 592. 592. So what is the value of error of 2? Plus 2. Error of 2 is this address 2 2. Starting address is 600. We are adding plus 2 means it is pointing to next element. That means 602. With the value of error of 2 2 and then 2. This is the element. Second block, second row 0, second row and then second element 0 1. This is the element. This is called garbage value. For suppose here we are writing address of error of 2 2 and then 2. Error of 2 is second block, second row, second element, address. In between 600 and 610 there is a addresses called 602, 604. 012 606. That means this address is 604. Hey everybody, welcome to SMR Telugu Education. So what is the output of a given program? What is the output of given program? Here the array size is int error of 3, number of rows 3, number of columns 4. So first one is error of 0, error of 0, next element error of 1, next one error of 2. These are the base addresses of an array. Error of 0 is the base address of this array. Error of 1 is the base address of this array. Error of 2 is the base address of this array. Here the base address is 500. Base address is 500. Next address is total 8 bytes. That means next address is 508. Next address is 516. This is the first element, second element, third, fourth element. The first element, second element, third, fourth element. Next one is error of 00, 01, 02, 03, 10, 11, 12, 13, 20, 21, 22, 23. This address is this first address is 500. This address is 508. This address is 516. Next, error of 0. Array name is always gives base address of an array. Here the array name is error. So error always gives the base address of an array. Here error of 0 is this is the error of 0, one array, error of 2, another array. This one is error of 1 is another array. The first element is 4, 14, 24, 34. Next is 6, 16, 26, 36. Next one is 9, 19, 29, then 39. this address is 500. Next address is 502, 504, 506. Next address is 510, 512, 514. Next 516. So next address is 518, 520, 522, 'Next, this is the int asterisk PTR of 3. So array size is 3. Array size is 3. First element is PTR of 0. PTR of 0. Next element is PTR of 1. So PTR of 0. Next one is PTR of 1. Next element is PTR of 2. The array name is PTR. PTR gives the base address of an array. So the address is 600. Array name is PTR. PTR always gives base address of an array. The first address is 600, next address is 602, next address is 604. Initial values is garbage values. Here the garbage values. Next one is int asterisk asterisk PPTR. So array name is, variable name is PPTR. In some address 700, initial value is garbage value. Next, PTR of 0 is equal to AR of 0. AR of 0 always gives base address of this array. PTR of 0 is 500. AR of 1 is gives the base address of this array. The base address is 508. Next, AR of 2 gives the base address of this array. Base address is 518. Here PTR of 0 value is, base address of AR of 0 value is 500. That means this one is pointing to this location. This one is pointing to this location. Next address is 508. PTR of 2 is 516. So this one is pointing to this address. This one is pointing to this variable. Next one, AR of 2 is 516 is pointing to PTR of 2. PTR of 2. This one is pointing to this address. Next, PPTR is equal to PTR. Here PTR value is base address of array. Base address of array is 600. This 600 is stored in PPTR. Next, this one is pointing to this address. Next one, I value is 3. So I value is 3. So 3 greater than or equal to 1. Yes, condition true. Asterisk PTR plus is equal to I. I value is 3. What is PPTR? PPTR is 600. What is asterisk PPTR? Asterisk PPTR is 600 address variable, that is PTR of 0 is increment by 3. PTR of 0 value is increment by 3. That means PTR of 0 is pointing to 500. It is increment by 3. That means it is plus 1 means pointing to this one. Plus 2 means 24. Plus means 34. Now this value is changed to 506. This value is changed to 506. Now this one is pointing to 506. This one pointing to this one. (34). That means error of 0 3 element. Next, asterisk PPTR is, what is PPTR is 600. Asterisk PPTR means 600 address variable, that is PTR of 0, value is 506. Asterisk means 506 address variable. 506 address variable is 34, is increment by 3. That means this value is increment by 3. Now this value is changed to 37. Next, plus PPTR. Now the PPTR value is increment by 1. That means here the value is 602. Now this one is pointing to this location. This link is deallocate. Now I value is 2. Now I value changed to 2. So 2 greater than or equal to 1. Yes, condition true. What is PPTR? PPTR is 602. Asterisk PPTR is 602 address variable, that is PTR of 1, is increment by 2. That PTR 1 value is 508, is increment by 2. That means increment by 1 means 510, increment by 2 means 512. So this value is changed to 512. Now this one is pointing to 512. This link is deallocate. Now what is asterisk, what is PTR, what is PPTR? PPTR is 602. 602 asterisk PPTR is 602 address variable, that means PTR of 1. Asterisk means PTR of 1 address, PTR 1 value is 512. So 512 address variable, that is a error of 1 10 11 12, error of 12 is incremented by I value is 2. Now this value is changed to 28. Next, plus PPTR. PPTR value is 602 is increment by 1, that means this one is pointing to next 604. 604. Now this one is pointing to this address. So this link is deallocated. Now I value is decrement by 1. Here I value is 1. So 1 greater than or equal to 1, yes, condition true. What is PPTR? PPTR is 604. Asterisk means 604 address variable, PTR of 2 is increment by 1, that means PTR of 2 is pointing to, increment by 1 means 5, it is pointing to next address, that means this value is changed to 518. 518. Now this one is pointing to this address. So this link is deallocated. So what is asterisk? What is PPTR? PPTR is 604. Asterisk PPTR means 604 address variable, that is PTR of 2 is replaced here. Next, asterisk PTR of 2. PTR of 2 address is 518. 518 address variable is error of 21. This value is increment by 1. That means this value is changed to 20. Next, plus PPTR. PPTR value is increment by 1. This value changed to 60. 606. Then this link is this one is pointing to 606. Next, I value is 0. I value is 0. So 0 greater than or equal to 1. Condition false, out of the loop. Next, this statement is executed. PPTR is 606 is decrement by 1. That means this value is 604. Now this one is pointing to this address 604. Next, printf %/n %d. What is PPTR? PPTR is 604. Asterisk PPTR is 604 address variable, PTR of 2. Asterisk means Here replaced with ptr of 2. ptr of 2 asterisk means 508 address variable, that is ARR of 2 1, value is 20. So 20 is printed. Here so 20 is printed. Next one is I is equal to 0, I less than 3, condition true, ptr of asterisk ptr of 0. Here ptr of 0 is 506, asterisk means 506 address variable, that is ARR of 0 3. This value is 37 is printed. Space. Next I value is increment by 1. Next here I value is 1. I value is 1. So 1 less than 3. Yes, condition true. Asterisk ptr of 1. ptr of 1 is 512. Asterisk means 512 address variable. Address variable. ARR of 101112. ARR of 12. Value is 28. So 28 is printed. Next I value is increment by 1. I value is 2. I value is 2. So 2 less than 3. Yes, condition true. Asterisk ptr of 2. What is ptr of 2 is 518. Asterisk means 518 address variable, that is ARR of 2021. ARR of 21. Value is 20. Here the 20 is printed. Next I value is 3. 3 less than 3. Condition false, out of the loop. Next R value is 0. R value is 0. 0 less than 3. Condition true. Next control goes to next statement. C is equal to 0. C is equal to 0. 0 less than 4. Condition true. ARR of 0 0. 0 0 value is 1. Next 0 1. Next C value is incremented by 1. 1 less than 4. Condition true. 0 1. 0 1 value is 14. I think this value is 4, not 1. This value is 4. 4. Here 4 is printed. For 14. Next R value is increment by 1. C value is increment by 1. C value is 2. 2 greater than 4. Condition true. 0 2. 0 2 value is 24. Next 0 3 value is 37. Next C value is 4. 4 less than 4. Condition false, out of the loop. Next R value is increment by 1. So 1 0 1 1 1 0 1 1 1 2 1 3. It printed 6 16 28 36. Next C value is 4. 4 less than 4. Condition false, out of the loop. Next R value is increment by 2. 2 less than 3. Yes, condition true. Next statement. C value is 0. 0 less than 4. Condition true. 2 0. 2 0. Value is 9. 2 1. Value is 20. 2 2. Value is 29. 2 3. Value is 39. So 9, 20, 29 and 39. So this is the output of a given program. Okay, we have to execute this code. Alt F new F2. So file name is pointer.c. Yes. So void main. Here you have to take two-dimensional array of size 3, 4, number of rows, number of columns. Here assign the values. Four, 14, 24, 34. Comma, comma. The values is 6, 16, 26, 36. The values is 9, 19, 29, 39. Next, int asterisk ptr of array size is 3, int asterisk pptr. Next, I value is number of rows, number of columns, and clear the screen clr scr. Here you have to write for I is equal to, first assign the ptr of 0, value is equal to ar of 0. Next, ptr of 1 is equal to error of 1. Next, ptr of 2 is equal to error of 2. Next, pptr is equal to ptr. Now we have to write for loop I is equal to 3, I greater than or equal to 1, I minus minus, or I is equal to I minus 1, anything I minus minus. Here first you have to asterisk pptr plus is equal to I, asterisk asterisk pptr plus is equal to I plus plus pptr. After the loop you have to decrement the pointer pptr. Next you have to printf /n %d comma asterisk asterisk pptr. Next you have to write the printf. After printing you write /n for new line, for I is equal to 0, I less than 3, I plus plus, then printf %d space comma asterisk ptr of I value. Next print number of rows and number of columns. For rows is equal to 0 or less than number of rows is 3 r plus plus. Then every time output is new line you have to add printf /n. Then print number of columns. For column is equal to 0, c less than number of 4, c plus plus. And then printf %d space comma error of number of rows, columns. Error of 0, 0, 0, 0, 1, 0, 2, 0, 3. Next time 1, 0, 1, 1, 1, 2, 1, 3. 2, 0, 2, 1, 2, 2, 2, 3. Save this file, F2, Alt F9, yes. You will get an errors. Error. Type, we have to mention the type of integer. Okay, Alt F9, yes. Control F9. We have to debug this code. Windows watch, here watches, add watch error. Next ptr of add watch ptr. Next pptr. So F7, yes. This is the error of 0. This is error of 1. this is error of 2. Your initial values is default values. This base address is stored here. This base address is stored here. This base address is stored here. So this is base address, this is base address, this is base address. Next, Windows watch. So PPTR value is PTR base address. Now PPTR is pointing to this address. Now I value is 3. Then this one is pointing to this way, this address 30, this address 34 address variable. This value is changed. Now this value is changed to 37. Yes. Next PPTR, this value is changed. Now PPTR is pointing to this address. Now PPTR is pointing to this address. This one is pointing to +4, 508 +4 pointing to this. Now this value is changed to 28. This value is changed to 28. Next PPTR is increment by 1. Now this PPTR is pointing to this address. This one is pointing to this. Here I value is increment by 1. Asterisk PPTR means this address variable. This one is increment by 1. That means this value is changed now. This one is pointing to this address. For this statement, this value is changed. E6. Now for this statement, asterisk PPTR is this one. Asterisk means this value. Error of 2 1. This value is increment by I. I value is 1. Increment by 1. This value is 20. Now PPTR, this value is increment by 1. This one is 6. Once again we are decrementing. This one is 4. Asterisk PPTR is, now this one is pointing to this address. This one is pointing to this address. This one is 604. 604 is pointing to this address. Asterisk means 20. Alt F5, 20 is printed. Now this address is pointing to this variable. This one is pointing to this variable. This one is pointing to this variable. PTR of 0 means 37. Asterisk PTR of 0 means 37. Alt F5, 37 is printed. Next, asterisk PTR of 1 means pointing to this address. 28 is printed. Alt F5, 28. Next F7, this one is pointing to this one. 20 is printed. Alt F5, 20. Next F7, number of rows and number of columns. So 0 0 0 0. Alt F5, 4 is printed. 0 1 0 1 0 2 0 3. Alt F5, 4 14 24 37. Next R value is 1 1 0 1 1 1 6 is printed. Alt F5, 6 16 28 36. Alt F5. Next R value is 2, C value is 0. 2 0 9 9 20 29 39. Alt F5, all the elements are printed. Okay, F7. So you have to debug this code. We have to learn lot of things. One more thing, here by using pointers concept, you have to print these values without writing R and C. Here are error of R can be written as, how can I write this one? Asterisk of error plus R. Both are same. These two are same. Similarly, ARR of R and C. This can be written as asterisk ARR plus R plus C. This can be written as like this. If this gives the address, we want that value. Once again we have to write asterisk of asterisk ARR plus R plus C. This is by using pointers. So instead of writing this one, you have to write asterisk of ARR plus number of rows plus C, number of columns. This gives the address. Asterisk means variable at that address. Alt F9, yes, Control F9, same output. Alt F5. Just you have to write the clear the screen. That's why it prints the same output. Alt F9, yes, Control F9, Alt F5. By mistake, if you write without writing star, it prints the addresses. Continuous 00, 01, 02, 03, 20, 21, 22, continuous addresses. Alt F5. First address is 942, 492, 494, 496, 498 and 500, 502, 504 and so on. Continuous addresses. Okay, this is the difference. You have to access by using array index operator or by using pointers concept. Number of rows and number of columns. Alt F9. Write %d. Alt F9, yes, Control F9, Alt F5. Okay. So still you have any doubts? Please refer once. Thank you for watching. Hi everybody. Welcome to SMR Telugu Education. Next topic, write a program to find matrix multiplication. Matrix multiplication. Here I am taking the matrix elements 1, 2, 3, 4, 5. Six, 7, 8, 9. Once again 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. So this is one matrix. The size is number of rows is 4 and number of columns is 5. This is 4 by 5 matrix. So another matrix 1, 2, 3, 4, 5. So this is another matrix. Number of rows is 5. And then number of columns is 5. And then number of columns is 5. 5 by 5 matrix. Here you have to calculate the multiplication of two matrices. So if you want to multiply two matrices, here this one is one matrix. Here I am taking M2. This one is another matrix M2. M1 matrix is number of rows is 4 and then number of columns is 5. Here the number of rows is second matrix is, here you have to enter number of rows of first matrix and number of columns of first matrix. Next you have to enter the number of rows of second matrix R2, then number of columns of second matrix. Here in mathematics one rule is there, the number of columns of first matrix, the number of columns of second matrix is equal to the number of rows of second matrix. The number of columns of first matrix is equal to number of columns of second matrix. This both should be equal. For suppose here the number of rows, number of columns of first matrix is not equal to number of rows of second matrix, then matrix multiplication is not possible. For suppose here 4 by 3 and 2 by 3, at that time matrix multiplication is not possible. Here first you have to check the condition C1 and R2 both should be equal. First you have to check the condition. Up to this you have to write the code. F2 file name is matrix multiplication.c. Here I am write main. You have to take the input is two matrices of size integer. Matrix array name is M1 of size 4, number of rows is 4, number of columns is, better to take number of columns 10, then number of rows 10. So 10 by 10 matrix. M2 number of rows 10, then number of columns is 10. Next here you have to take into number of rows of first matrix, number of columns of first matrix, number of rows of second matrix, number of columns of second matrix. Just to clear the screen, CLRS here. First you have to enter the user, ask the user to enter the number of rows and columns. Enter rows of first matrix. Try to scanf, scan that one, address of R1. So copy this code, control insert and then enter, shift insert. So enter columns of first matrix. Columns of first matrix C1, and then ask the end user to enter the number of rows of second matrix and the number of columns of the second matrix. Copy, control insert, shift insert. Enter the number of rows of second matrix. R2, and then number of rows of columns of second matrix. C2. Here the condition is, here the number of columns of first matrix should be equal to the number of rows of second matrix. So both are not equal, then matrix multiplication is not possible. If number of columns of first matrix C1 is not equal to number of rows of second matrix, both are not equal, then give some message printf /n, matrix multiplication not possible. Then go to end, semicolon, then control goes to this end label. Here I am giving end label. So up to this you have to run this code. Alt F9, yes, control F9. Enter the number of rows of first matrix is here I am giving 2, number of columns of second matrix is 3. The number of rows of second matrix is some 4 and then 5. Number of columns of second matrix is 5. First condition 3 is not equal to 4. Yes, condition true. Then this code is executed. Matrix multiplication is not possible. Alt F5, matrix multiplication is not possible. First matrix, and then give some space, first is T. Matrix multiplication is not possible. Next, you have to save this one. Okay, now here the number of columns is 5 and then number of rows is 5, then both are equal, then matrix multiplication is possible. You have to multiply this one. How to multiply? This rows, multiply this row with this column. This one is matrix, the number of rows, this one is 0, first, second, third. This is the columns, 0, 1, 2, 3, 4. So just 0, 0 element is 1. Similarly here the number of rows, 0, 0, 1, 2, 3, 4. The number of columns is 0, 1, 2, 3, 4. So here you have to multiply the first row. So please remember the resultant matrix, whenever you are multiply these two values, the resultant matrix the number of rows is equal to the number of rows of first matrix. The resultant matrix number of rows is equal to the number of rows of first matrix, and the number of columns is equal to second matrix columns C2. When I have to multiply these two values, multiply these two matrices, the resultant matrix M3 this one is M2, the resultant matrix M3 number of rows is equal to the number of rows of first matrix, and the number of columns is equal to the number of columns of the second matrix. So this one is 4, this resultant matrix is number of rows is 4, number of rows is 4, number of rows is 4 and number of columns is 5. This is 4 by 5 matrix. The number of rows is 0, 1, 2, 3. Then number of columns is 0, 1, 2, 3, 4. First this element, how to get this element, how to get 0 0 element. 0 0 element is equal to 1 into 1 plus, you have to multiply this one, you have to multiply this one into this one, 1 into 1 plus 2 into 1 plus 3 into 1 plus 4 into 1 plus 5 into 1. This result will be stored in the 0th element M3 of 0 0. So here 1 into 1 plus 2 into 1 plus 3 into 1 plus 4 into 1 plus 5 into 1. Here what is 1? Here 1 is M1 of 0 0. Here we have to multiply M1 of 0 0 in this one element is M1 of M1 of 0 0 into this one is M2 of 0 0. Next one is plus next this 2 is M1 of 0 1, M1 of 0 1 into this 2 is M2 of 0 1. M2 of number of rows, first row is 1 and then 0. This element is M2 of this element is this one M2 of 1 0, M2 of 1 0. Next plus this one 3 into 1, this 3 is m1 of 0 2 into 1. This one is m2 of number of rows is 2 and then number of column is 0. This one value is m2 of 2 and 1, m2 of 2 1. This 3 value is m1 of 0 and 2. Plus next 4 into 1, 4 into 1, this 4 value is this one m1 of 1 3, m1 of 0 3 into this one m2 of number of row 3 0. m1 of 4 is 0 3 into m2 of this one is number of row 3 and then number of column is 0. Plus 5 into 1, 5 into 1, this 5 is m1 of 1 5 into this one is m2 of 4 0. m1 of 0 4 into m2 of number of rows 4 into 0. This is sum. This is sum. You have to calculate this sum and write here. Okay. Yes, so please observe. This one is 0, this one is 0, this one is 1, this one is 1, this one is 2, this one is 2, 3 3, 4, then 4. This is the first one is whenever this loop, in this loop this number of rows, third matrix m3 number of rows is equal to the number of rows of first matrix. R1 is the number of rows and resultant matrix m3 matrix number of columns is equal to the number of columns of second matrix R1 and C2. Now this is the outer loop. See, outer loop is number of rows 0, so number of rows is less than R1 R plus plus. This is the outer loop. If the number of rows is equal to 0 to 3. this is the number of rows. The number of rows is equal to 0 to 3. Next, number of columns. This is outer loop. In the outer loop you have to write inner loop. Here the number of rows, number of columns is equal to 0. Number of columns less than or equal, here the number of columns of third matrix is equal to the number of columns of second matrix, that is C2, then C++. Now this is the outer loop, this is the outer loop, this is the inner loop. Now we have to write one more loop to calculate this sum. So initially the initial the array default values is garbage values. Whenever we are declaring M3 matrix, the default value of 0 0 is garbage value. Next 0 1 is garbage value, 0 2 is garbage value, 0 3, all are garbage values. Here you have to multiply these two values, multiply this row with this column, then you have to add these values. So first you have to initialize the each element of matrix M3 is 0. Here we have to initialize M3 matrix of number of rows and number of columns is equal to 0. Now here observe, three, these are same, 4 4. Here you have to write one more loop called innermost loop. This is the outer loop, this is inner loop. The innermost loop you have to write this one as a loop. So when this one loop is repeated first time, the sum is stored in M3 of 0 0. So please remember, here the addition is how many times? This one is one time, this one is second time, third time, fourth, and then fifth. So this addition, how many times addition is depends on this value, columns of first matrix and the rows of second matrix. This value should be equal, that means the innermost loop is repeated how many number of times, either C1 or R2, both are same. So this loop is repeated the number of C1 or R1, here you have to write. So here the innermost loop, the number of rows, starting value is fixed 0 up to 0 to how many times, this addition is 5 times. Here you have to write here I am taking t is equal to initial value is fixed t less than how many times, either C1 or R2, both are same, so t plus plus. So here the starting value is 0. We have to multiply these two values, m1 of row and m2 of column. So first matrix number of rows, first matrix m1 number of row, that's why here you have to write m1 of r and m1 of m2 of column. This one is column. This 0 0 should be, here you have to write t starting value is 0, t starting value is 0. First time repeated, this sum is executed. Second time t value is 1, this sum is calculated. Innermost loop third time is repeated, then t value is 2, next time t value is 3, next t value is 4. Here you have to write this statement. So m3 of number of rows then column is equal to m3 of number of rows and column plus, so initial value is 0, 0 plus 1 into 1, 1. So how to write this one? You have to multiply m1 of number of rows, number of columns into m2 of number of rows and then number of columns. So this statement is very important. Here the first matrix m1 of number of rows and then m2 number of columns. Here the m1 here you have to write t, here you have to write t. Whenever this loop is repeated first time, so whenever this loop is repeated first time, you have to 1 into 1, 1. So this value is 1. This loop is repeated second time, t value is incremented by 1. This one is calculated 2 into 1. Next, so this loop is repeated, t value is incremented by 2. Then this value is, this sum is added to this variable. Next, this loop is repeated third time. This one is calculated. This one is calculated. This sum is added to matrix. Next time, this sum is calculated and added to this variable. Whenever this t value is incremented by 1, this condition is failed. This one is out of the loop. Next, whenever the first time this one is executed, the sum is stored here. m3 of 0 0, number of rows is 0, number of columns is 0. So 1 into 1, 1. One, 2, 3, 3 into 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. First, next one is first row and then second column, calculated and stored here. Next element, first row and second column, stored here. First row and then next columns. Okay. So this is number of rows and number of columns. So this one is, this loop is for number of rows. This loop is for number of columns. Number of columns. This innermost loop is for to calculate sum. So calculate sum. So now we have to convert this one into our code. Here you have to ask the end user to enter the first matrix elements /n enter first matrix elements. For you have to take number of rows and number of columns, rows and columns. So first r is equal number of index starts from 0, r less than number of rows of first matrix r plus plus. Here ask the end user to enter printf /n enter percentage row elements, first row, second row, third row elements. So first r value is 0, that's why here I am writing r plus 1. That means I have to first row, second row, third row message to scanf percentage d comma address of first matrix m1 number of rows r once again loop number of rows and then number of columns. For columns c is equal starts from 0, c less than c1 and then c plus plus. Now ask the end user to enter first column element printf /n enter percentage d column element. So first column, second column, third column up to then scanf percentage d comma address of m1 number of rows and then number of columns. This code is for scanning the first matrix elements. Copy, control insert, paste, shift insert. So printf /n enter second matrix elements. Second matrix elements, here the number of rows is 2. Enter here the number of columns is c2 and then scan the here is m2 of number of rows and m2 rows and columns. Now we have to logic for matrix multiplication. Matrix multiplication. Here I am taking the number of rows of a third result matrix. Result matrix number of rows is equal to the number of rows of first matrix and number of columns of result matrix is equal to the number of columns of second matrix. Here I am writing for third matrix you have to declare that matrix m3 of number of rows and then number of columns, taking r3 comma c3 variable declaration. So for this outer loop is for number of rows, r is equal to 0, r less than number of rows of R3, number of rows of result matrix is equal to number of rows of first matrix, number of columns of result matrix is equal to the number of columns of second matrix. So R less than R3, R plus plus. This is the outer loop for number of rows and then number of columns. Inner loop is for number of columns. C less than C2, C plus plus. Here you have to matrix for elements default value is garbage value, that's why here m3 of number of rows and number of columns. Initial value is 0. Here you have to write innermost loop to calculate sum. So t is equal to 0, t less than, that addition is equal to, this addition is equal to the number of first matrix number of columns or second matrix number of rows, both are same. So this innermost loop is repeated either C1 or R2. So t plus plus. So how to write this sum? M3 of number of rows and then number of columns. You have to add m3 of number of rows or number of columns plus m1 into m2. Here m1 of number of rows, m2 of number of columns. It is the number of rows of first matrix is multiplied with number of columns of second matrix. That's why I had to write RC. Here to write T. You have to declare the variable T of type index. For index purpose you have to use of type int T F2. Save. Yes. So this is the logic for to write matrix multiplication. Next you have to print the result matrix. So for number of rows, r is equal to 0, r less than, first you give the some message, printf slash n result matrix is for number of rows, r is equal to 0, r less than r3, then r plus plus. For number of columns, c is equal to 0, c less than c3, then c plus plus. For every row, you have to enter printf slash n. So every time the control goes to next line. So print the values. Printf percentage is some space, comma, m3 of number of rows and then number of columns. So F2, save. Yes. Now you have to run this code. Alt F9. You have to get errors. Here miss the parenthesis. Alt F9. Yes. One more. You have to copy paste maybe. So Alt F9. Yes. Control F9. Okay. So Control F. So first once again you have to run this code. You have to give in the same values. 4, 5, 5, 5. First element 1, 2, 3, 4, 5, 6, 7, 8, 9. Once again 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. Now second matrix, first row, first column 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Here the first element is 15. Alt F5. Here the first element is the first element is 15. Enter. Okay. So this is the matrix multiplication. So alt F9, yes, control F9. So number of first matrix, number of rows is 2, number of columns is 2. Second matrix 2 by 2 matrix, the elements is 1 0 0 1 or 0. Second matrix 1 2 3 4, alt F5. The result matrix is 1 2 1 2. So here debug this code. So it will take time to debug, so please remember. So this is the matrix multiplication. So still you have any doubts, please refer once again. Thank you for watching. Bye.